Oh, okay. She's still not here. All right. Justina Darcy. I heard a yay back there. Woo. Okay. You're here. Next, we have a Shipwrecks book of the Sunshine State, 2 little reef balls. Is it autographed? Sweet. All right. This one. These are really cool. On those steps. It's by Michael Barnett. So yep, and it is signed. Very cool. Patrick Smith. Patrick. Here, present. And finally, the coolest reef ball that they brought from the 60s, as well as the Eternal Reef shirt. Let's see. Candy Hansard. Candy in the room. All right, Candy, you got it. All right, Joy, you got it. Outside tonight? Or not outside tonight?
And then change to start.
Yeah.
So welcome back, everybody. How was lunch? Is it good? Remember, I'm the food person, so I want to check on that. Because this is what we do. We have another announcement to make. The poolside reception tonight will not be poolside. I've been informed by quite a few people who may or may not be from South Florida that it's too cold to be outside. So, and it is pretty cold. So we're going to have the networking reception in the same place we had last night. Okay. So we are going to continue with the ecological application session, and our moderator for this afternoon, whose job is to keep you all awake in your post-lunch food coma, Pat Quinn.
Now, my job is to introduce the people that are going to keep you awake. So I'll be dozing right over there. Okay, so first we have Chris Stallings from the University of South Florida, integrating basic and applied ecology using paired artificial natural reef systems.
I'm actually bringing my timer so that that 3 minutes doesn't sneak up on me again. Start. So I am talking about something that I know a lot more about than boat detections. Although one gentleman mentioned that we did have a bad red tide earlier this year, and we were at the southern end of the red tide, which might explain some of those decreased boat visitation rates that we talked about. Also, it was within the error of the 2 years. So statistically speaking, they weren't different, even though it was a depression. Okay, anyway, enough about this morning's talk. Thanks to Sea Grant and FWC for hosting this conference and for inviting me to come speak a little bit about what we've been doing on artificial reefs. But I figured this was I'm going to talk a little bit about integrating basic ecology and applied ecology and some of the work that we've been doing on paired artificial natural reef systems. But I thought that this was a great opportunity to get a lot of people that are thinking about artificial reefs together. And so I'm going to change the talk and change the content of the talk a little bit from what's in your program to ramblings about why we need to rethink the what, where, and how we deploy natural or artificial reefs. And I want to say that my co-authors are completely innocent of any crimes that I may commit. So here we are. This is the webpage for the conference. The title of the conference is Navigating Expectations and Charting Objectives. And I think that this is a really appropriate title for this conference, given where we are right now in our scientific understanding of how artificial reefs function. Okay, so we all know what these words mean, but an expectation is a strong belief that something will happen as a result of some kind of action, in this case, a deployment of a natural reef or an artificial reef. And so as scientists, we like to think of this in a predictive manner. And an objective, of course, is something that is aimed at or sought, concisely defined as a goal. Now, the FWC Artificial Reef program has 6 well-defined goals. I'm not going to go through each of these. Instead, the 2 that really grab my attention are these 2 here. So if we combine these 2 goals with our notion of what are our expectations, we can ask, what are these expectations about how artificial reefs function ecologically and as a component of fisheries management? Now, as has been mentioned a few times already, there are approximately 3,000 reef complexes in the state of Florida and in adjacent federal waters. They come in a variety of materials, shapes, sizes, configurations, distances from shore, etc. And this is just me going on Google Images and stealing some images. Those of you that went to my talk on Monday about this may notice that the General Lee is no longer in there. Instead, I've replaced it with a truck, which I think is from the Panhandle of Florida. So these are supposedly reefs from state and federal waters off of Florida. Some may or may not be accurate, but this is a little bit of a grab bag of the different types of reefs that we have deployed in our coastal waters. And so as a scientist, I asked, can we predict the ecological functions of these artificial reefs, given this wide variation in the sizes, the relief, the configurations of these different artificial reefs? It's a very uncontrolled, as we see it as scientists, it's a very uncontrolled question. And these are some of our data. We've got some studies going on off the Florida Panhandle in these paired artificial reef blocks, and then some locally here. You guys have already seen this map from this morning. These are some of our sites that we're measuring boat visitation, but also the fish abundances, fish richness, etc. So, you know, just not to kind of go through these data with detail, but in some ways, artificial reefs are functioning like natural reefs, and in some ways they're not, okay? So as a scientist, to try to tease apart, well, why are they functioning the same in some instances and functioning different in others? That's what's of interest to me. And the only way that we can really get at these kinds of questions is to conduct a controlled experiment. And I had the opportunity to work in an experimental system in the Bahamas where an experimental matrix of artificial and translocated coral reefs were built. Now, by translocated coral, I mean the scientists actually took coral heads, living coral heads from one area and moved them to another area. They moved them out here to an area that's all sand and seagrass. Imagine the permits for that in the United States. You know, that's part of the reason why this was done in the Bahamas. I got to study Nassau grouper in the Bahamas, you know, and it was a one-page application. You know, try studying Nassau grouper in the Bahamas, or in the United States. So these reefs are a combination of these building block artificial reefs and these translocated coral reefs, and they were built to standardize some of these variables that I mentioned earlier. They're the same size, relative same complexity, same relief, same level of isolation, and they were built to mimic these nearby natural patch reefs in the area. Okay, so this gives us a really good opportunity to see how these different reefs are functioning ecologically in a highly controlled situation. And when I arrived in the system, there were over 20 years of data that had been collected, and I continued to collect some data. And when I plugged these into a multivariate ordination approach, which determines whether the reefs are different or are they the same, I was kind of surprised that, first of all, how much noise was in there, but despite the noise, the artificial reefs were very different from the natural reefs in the types of fish and the abundances of fish that were on them. And, so, you know, kind of interestingly, these translocated patch reefs were intermediate. And that's kind of interesting because these translocated patch reefs are part artificial, part natural. Okay, so despite this highly controlled system, we're seeing high dissimilarity among these reef types. So then how do you tease all these different reef types apart relative to the natural reefs? It's really difficult. Bill Lindbergh, just north of here, did some experimental work as well, where he controlled the reef size and spacing. And he focused on gag grouper, and he's going to talk about that in 2 talks. I don't know if he's going to talk about this, but he's going to talk about gag and parts of the system, I hope. And one finding is that there are more fish on larger reefs. Okay, so that's an expectation, to go back to the central point here, that's an expectation that we can in general have about both artificial reefs and natural reefs. The bigger they are, the more fish they'll hold, usually up to at least a certain point. However, some of the other ecological processes like colonization rate and residency we're affected by these interactive effects of reef size and spacing. And again, we're focusing on expectations and predictions. And anytime we have an interactive effect, our predictive power can be compromised by it. In other words, we need to know not only how one thing is going to respond to another, but what level a third variable is at. It's difficult to set that into a predictive format. Sticking with GAG and going back to something that was said yesterday as well as today, Steve Bortone mentioned location, location, location. Here's a very crude life history diagram of the GAG. They settle in seagrass beds. They live there in their first spring and summer. They move offshore before their first winter into these shallow natural reefs. And as they get older and larger, they'll continue to move offshore and join the adult population. I've heard it repeated multiple times that fishermen want structures inshore. And that gives them a benefit of being able to access these reefs without going too far offshore and possibly catching a legal-sized fish. The problem with that, potential problem anyway, is that we've observed larger GAG on these inshore reefs than we would expect to see if there were no artificial reefs in the area. Okay, so maybe that's another benefit from the perspective of being able to not have to go very far offshore to catch a legal fish. That's a benefit. That's good. However, as these juveniles move out of the seagrass bed, they may encounter higher densities than they would otherwise encounter. And we may expect some density-dependent effects. And this is science talk for basically, as you increase the density, the per capita growth rate goes down, and the per capita mortality rate goes up. And that's biology. That's population biology 101. The other thing is that these bigger GAG can be cannibalistic on these smaller GAG. Okay, so this is an unintended, perhaps unexpected, negative effect. We also see this with red snapper, another economically important species. Reefs that are located far apart from each other, 500 meters or more, have higher densities of age 0 fish when they are 500 meters apart from reefs with age 1 fish, compared to reefs that are only 15 meters apart. And there are multiple mechanisms why this might be, but two of the most likely mechanisms are aggression and, again, cannibalism by the age 1 fish on the age 0 fish. Okay, so location is really important, especially from an ecological perspective. Okay, so can we predict the ecological functions of artificial reefs given this wide variation and uncontrolled factors? Well, in some cases, yeah, we can, but in a lot of cases, we can't. It's extremely difficult. And this is confounded by the fact that a lot of the studies that do this use all kinds of different methods in order to tease these apart. And so if you're looking through the literature and trying to make sense of it all, trying to come up with some kind of general pattern, it's extremely difficult. We see high variance and dissimilarity even in highly controlled systems, such as the experimental system I showed you from the Bahamas. Okay, so why the uncertainty? Well, Craig Osenberg and colleagues, including Bill Lindbergh, published a paper in 2002 that I think does really well to summarize some of the key reasons why we might be seeing why we might be experiencing a high level of uncertainty about how artificial reefs function, especially relative to natural reefs. First of all, marine systems are simply very noisy. And I don't mean noisy in the way I talked about this morning. The data are very noisy. There's a lot of variability out there. And so separating that variability from the effects of how a reef is operating is incredibly difficult. Many artificial reefs have been deployed without any kind of predefined scientific program to study their effects. This is something I'll come back to at the end of the talk. This paper was published in 2002. I think this has changed a little bit, as we'll hear today. Many investigations conducted so far have focused primarily on the artificial reefs, without a lot of attention on the natural reefs. We've seen that that's not necessarily true anymore. We've heard some talks today. Will Patterson's going to talk about his paired systems a little bit. And so I think we've improved upon that in the 10 or so years since this paper came out. So good job there from a scientific perspective. And then the last one here, and this is, to me, this is the elephant in the room, and this is one of the more contentious issues, is that artificial reefs may simply affect distribution by attracting them off the natural reefs and concentrating them on the artificial ones. Okay, so that gets us to the other piece here. How are artificial reefs a component of fisheries management? Well, this is a graph drawn by Jim Bonsack from a paper in 1989. And the idea here is that if we add no additional reefs, our total annual catch, our total annual biomass, whatever we're measuring, is maxed out. Okay, so this will be a habitat limited scenario. But if we add reefs, we're going to see more fish. More reefs equal more fish. And we heard a talk this morning, a very good study done in Southern California, in which Jennifer Graneman and Mark Steele showed that production on these artificial reefs can be quite high. Okay, so in order for these artificial reefs to increase the overall regional production, they have to produce more fish. Production has to be high, and it can be, and it definitely can be. However, I would argue, just as Steve did this morning, just as the international community agrees, that we still haven't address the relative effects of production and attraction. I'm going to propose a way that we move forward on this. There are many different influences. Here's just a snapshot of some of those that will determine where on this continuum, as Jennifer mentioned this morning, we are. Yeah, we're probably not always at one end or the other. But I've heard multiple talks that have certainly mentioned that attraction is certainly going on. You know, putting out a reef and seeing red snapper and black sea bass within a few hours, that's attraction. If we have, this should say natural reef availability. So if you have no natural reef in a region, such as off of maybe Alabama, and you start putting out artificial structure, then what you're seeing is primarily production. So where you are on that continuum is important. Fishing intensity, as I hope I convinced you this morning, the fishing intensity on the on the artificial reefs is much higher than on the natural reefs. And then these other ones are species specific down here. Okay, so how are artificial reefs functioning as a component of fisheries management? I would say that it's unclear right now. There's an elephant in the room, and I think we need to get at it. And so the rethinking part is, I propose that we use highly standardized impact studies whenever we deploy a new artificial reef. And the way to do that is using before after control impact studies. And that would look something like this. If we have a proposed site where we're going to deploy new artificial materials, we determine what are the nearby natural reefs, and these are our impact sites. By the way, I'm not inventing this method. This is the most rigorous method to do this. And then we go to another area nearby where we have no new proposed artificial reef, and again we look at some nearby natural reefs, and these are our control sites. All right, and so what we do is we go there 1 to 2 years before the deployment. This is the deployment of that new artificial structure. We measure biomass, abundance, richness, production, whatever it is that we're interested in, for whatever individuals that we're interested in, and we plot those out over time. And this is our control reef. And notice the noise in here. That's to capture what's really going on in the marine communities. Okay. Now, of course, we're interested in what happens on the artificial reef, and this is typically what we see. We see, an increase in biomass, production, whatever. The piece of interest here is what happens to this black line. If it continues to move in the way that it did before the deployment, and it's kind of mirroring this control reef, then we're not seeing attraction. We're not seeing strong attraction effects. However, if we see something like this, then that's an indication that we have strong attraction. And if you add that plus that, it's going to equal just about that. And so regionally, And I'm thinking, from a fisheries perspective, you have to think large scale. Regionally, this has done nothing to increase production. Okay, so here we are again on the continuum between no and a strong interactive effect or attraction effect. Okay, so the take-home points. Well, I would argue that we're currently, to use the title of the conference, we're currently navigating expectations in rough and unpredictable seas, and that I propose that we use a highly standardized Bakke approach for all future artificial reef deployments. Now, I'm a professor at a university, and I hate bureaucracy. I hate the red tape, and here I am saying that we need to do more. But that's the only way, in this case, that we're going to increase our predictive power, and we're going to finally get at this elephant in the room. And to use a second elephant, a lot of us in this room are touching different parts of this elephant, and we have different perspectives. And so this meeting is a great opportunity for us to come together at the same table and talk about this. Thank you very much. Do I have time?
You do. You got about a minute and a half.
Got about a minute. So I think we're doing things differently. So if anybody has any questions, comments.
Got about a minute and a half.
I saw one going to back, very back first. Yeah, those are both great questions. The first question is an issue of scale, and I don't have the answer. I think that's where we come together as a group, and we talk about the importance of scale. We talk about the different scenarios from the different regions. That's a key point.
Brian, over here. The reefs off of Alabama and the production potential. Considering the tiny size of that reefing zone compared to the entire Gulf of Mexico, relative to the 35 to 40% of the red snapper landings coming out of that reefing zone. The attraction production debate, I think, was answered by Dr. Shook. And he said, well, if these reefs are not producing these fish, then where are they being attracted from? And I believe there's a paper from Dr. Cowan out of LSU. He said that those fish are being attracted from reefs offshore of Texas. They were migrating to Alabama. It's like, that's crazy, but I agree with Dr. Ship on that one.
Yeah, and there are some other factors that have possibly led to the rebound in the red snapper population. But you're right. In putting together this talk, I think about Florida and think about how we have a mosaic of natural and artificial reefs. I haven't really thought too much about the different system off Alabama where they have very little natural reefs. It could be that some of the older artificial reefs are serving as what could be producing old fish. I don't know.
Chuck Morton, Hernando County. On the basis of what you were saying on, like a nearshore reef could make a young adult tend to move in. What if, when a nearshore reef's designed, the holes in the structure are not as large? In other words, they're made smaller for a juvenile reef so that, like a big grouper won't fit in there. And because I've heard several of us, we've got some we're trying to get permitted. I've heard people talking about doing a kayak reef, snorkeling reef, and it might require a modification of the module to have a smaller sized hole in order that you don't get this cannibalism. Would that be, there's a research project for somebody.
Yeah, no, I think that's a really good point. We're putting out, large ships, and we're putting out all kinds of high relief structures that don't exist naturally on the east or the west coast of Florida. And I picked up my brother-in-law from the airport yesterday after yesterday's meeting. He flew in from Ohio. He's an architect. He knows nothing about what we've been talking about. And I mentioned artificial reef. He says, I never heard of that. And he said, so what? It's trying to mimic the natural reefs? And I said, that's perfect. That's a perfect answer. It'd be great if we were, I think, more or less trying to mimic natural reefs and natural scenarios. I think I'm getting the hook.
Yep. We got to move on if we're going to stay on schedule here. Okay, next we have Will Patterson from the University of South Alabama and Dauphin Island Sea Lab, Ecological Function of Northern Gulf of Mexico Artificial Reefs, Comparisons to Natural Reefs.
Thank you, and thanks to the organizers for the invite. Going to continue the theme that Chris mentioned in this comparison between natural and artificial reefs. First, I'd like to acknowledge the co-authors on this talk, Louise, who's actually here, and then several former and current graduate students who actually did most of the heavy lifting here. Also, this work was begun when I was still in Florida at University of West Florida, and now currently I'm at University of South Alabama and the Dauphin Island Sea Lab. So in the context of artificial reefs, they're usually talked about, despite what Chris just mentioned about having to mimic natural bottom, they're typically focused, at least as a management tool, for exploited species. So you have a range of different fishes on the page here from many different families, but things they share in common is that they tend to be long-lived or moderately long-lived. Some of them are sex changers, which makes things complicated as far as their life history for fisheries management. And all of the fishes that you see here are estimated to be fully exploited or overfished. So we need to think about that in the context of management and artificial reefs. As has been discussed earlier, and Jennifer did an excellent job capturing some of the rationale here, and Chris followed up, but in the northern Gulf of Mexico, we have expansive areas that we've heard of off Florida and otherwise, where artificial reefs have been deployed. Here's a tank off Alabama that's tough to see because of the viz. Here's a module, rebar and concrete off of the panhandle of Florida. And a lot of the artificial reef commentary, and we just heard some questions reflecting this, is based on this perception that there's little natural reef habitat in the northern Gulf of Mexico. And where I am now off Alabama, this has been discussed quite a bit. But actually, along the shelf edge, from about 40 to 60 meters out to the shelf edge, there's expansive natural reef habitat. So when we say there's no natural reefs, we have to put it in context. Maybe within a couple-hour charter boat ride or a private fisherman's ride, there's no natural habitat. But actually, there's expansive natural habitat. And Sean Powers actually just did a recent analysis where he estimated that there was as much red snapper in this smaller spatial dimension area of natural habitat off Alabama than there was within the 3,000 square kilometers of artificial reef. So pretty remarkable finding for this area of the shelf that's not supposed to have any natural habitat. So in this context, we took a different approach than what Chris is talking about with an experimental approach, but instead we were curious, well, how do these structures function, getting back to the Florida objective? And so we have several different questions that we tried to address. One, does reef fish community structure differ between natural and artificial reefs? Again, it's difficult to have true controls here, but we just looked at what's out in the environment. Is there a difference in reef fish trophic ecology between natural and artificial reefs? Right? So is there a feeding benefit or some other benefit conveyed energetically on artificial reefs, which has been discussed by others? And then lastly, do reef fish have higher growth or lower mortality? Right? So getting at the population dynamics aspect of this idea of enhanced productivity, production as a rate. And obviously Jennifer discussed this in her thesis research a bit ago. So our system here is in the north central Gulf of Mexico. There's Dauphin Island. So we're south of Dauphin Island. You can see DeSoto Canyon coming up here. So our reefs are distributed between about 15 and 80 meters. The green circles are natural and the yellows are artificial. We studied these from 2009 to 2010. And originally this was meant to be a 3-year study, with this first year being sort of a reconnaissance year to start to look at demographic patterns and some of these ecological patterns. In the summer of 2010, we had a very unfortunate event in the northern Gulf of Mexico that delayed or disrupted our study. That's the bad thing. The good thing is that we had a year's worth of data out on the shelf that served as an excellent baseline to look at oil spill impacts. One of the methods that we use, Kristen Dahl referred to this earlier, is a micro ROV, and we use point count as well as transect methods depending on the habitat type. We can scale fish, get community structure estimates, and we can deploy this all the way across the shelf. So it's a method that we can standardize, and whatever bias then is random across our samples. We also sample fish with hook and line. I'll get to that in a bit. but to talk a bit about the community structure differences. So we have, I meant to mention, about 50 reefs, half artificial, half natural, that we studied across that time period. And what we estimated is there were about 25,000 individuals in our samples among 91 taxa, most of these to species. And there was a significant habitat and depth effects, but not a significant interaction. As Chris mentioned, that can be problematic when trying to examine what's driving some of these patterns. The diversity was much greater on natural bottom, about 50% greater as far as number of species. But the greatest differences that we saw were in some of these small demersal and benthic fishes. And so in the figures that you see here, these are the mean densities from our samples, and the solid bars are natural. The hatched bars, which may be difficult in the back of the room to see, are artificial, and the error bars here are standard error. Again, Chris mentioned that the data here often are noisy and high variance, and that's what we see. So we can see here that for damsels and wrasses, they have a higher density than some of these other small demersals, even on the natural bottom. But there's an order of magnitude difference, sometimes 2 orders of magnitude. So that's 2 decimal places, higher density on natural versus artificial. We have a few groups like the butterfly fishes and angel fishes, which actually tend to be similar between the 2 habitats, but fairly uncommonly, not uncommonly encountered, but low densities regardless of habitat. But again, this is the starkest difference we saw were in these small demersals. Among the fishery species, and we have a suite of them here, for some, like red snapper, I don't show tomtate here. It could be argued that tomtate's a fishery species in the northern Gulf of Mexico. We have much higher densities on artificial than natural. Again, an order of magnitude difference. Gray triggerfish is another example of that. However, for other species like amberjack, this is greater amberjack, gray snapper, a suite of different groupers, mostly gag, red, and scamp. We see that there's no difference statistically between the densities between these 2 habitat types. And again, these are standard errors. So for red snapper and gray triggerfish, we often hear in the northern Gulf of Mexico, north central, that artificial reefs produce these fish. Well, clearly they're high densities that are on these habitats. We can say that without a doubt. One thing that we're curious about is how does habitat type affect the feeding ecology of these animals? Does that convey some type of growth effect? And what we see here, these are pre-spill samples. Again, the goal was to have 1,000 stomachs. We had about 300 here, and then these are the stomachs which actually had prey items present. We can see that red snapper, as a model species, it's a very common species, so it's easy to look at some of these parameters. We have a diversity of prey items present in their stomachs. Interestingly, zooplankton, which are these top sections of the bar, actually make up a large percentage of red snapper diet. Jessica McCauley earlier concluded that on artificial reefs, high percentages of red snapper, or excuse me, of zooplankton and snapper diet may indicate that artificial reefs off Alabama were spaced too closely. But in fact, they're subsidizing their diet with zooplankton even on natural bottom. So what we know about red snapper is they're incredibly generalist mesopredators that eat everything. And so that's the take home here, that there's no artificial effect here, artificial reef effect on their diet. Down below is a different approach, and we saw some of this earlier from the work being done off Southeast Florida, where we have stable isotopes. So these are ratios of heavier to lighter stable isotopes. So they differ by 1 neutron in these for these different elements, carbon, nitrogen, and sulfur. And carbon is an indicator of the source of production. And where we are, we have benthic algae and we have phytoplankton. And so if we see differences in carbon numbers, it may be they're feeding on benthic versus pelagic food web sources. Nitrogen actually gets heavier as you move up the food web. So if they were feeding on different trophic positions, then we might see differences here in nitrogen between the artificial and natural habitat. Sulfur is a third stable isotope ratio that we look at. And for sulfur, if you're feeding up in the water column or on pelagic carbon phytoplankton production, for example, you would have a value closer to 19 or 20, versus if you're feeding on benthic sources, closer to 10. The great thing about sulfur is that stays pretty constant regardless of where you are on the food web. All right, so that's sort of a primer on stable isotopes. The take home here is for red snapper, there's no difference in any of these. They're almost mirror images. So regardless of artificial versus natural habitat, their trophic position is the same, their source of production is the same, They're feeding very similarly despite where they're found. If we look across a suite of species, and now we have carbon, nitrogen, and sulfur, again, you may not be able to see this in the back. These are all individual species across the x-axis. The take-home message is, across this suite of species that we examined, there's no difference in any of these isotopes, and these are standard errors, between artificially sampled fish and, artificial reef samples and natural reef samples. So amazingly, in this coarser look, using stable isotopes, we don't have significant differences across these species. So in fact, their trophic ecology is very similar between habitat types. What about growth? We've heard about growth and enhanced growth. Tomtate, red snapper. Tomtate's a small grunt. The scale here is different. We have 25 centimeters and 75 centimeters for red snapper. We age these fish with otoliths. And so this cartoon basically shows the green fish as a natural reef mean, the blue is artificial. No significant differences in growth rates for tomtate and red snapper, the two most abundant conspicuous reef fishes in the system. So we're not seeing that growth enhancement or a negative effect between the habitat types. We look at this with a little more statistical rigor than the cartoon I showed before. If we examine the natural versus artificial reef size at age for red snapper, there's no statistically significant difference in the slopes between those two data sources. So again, we conclude that there's no growth difference, positive or negative, between the habitat types. What about mortality? Jennifer talked a little bit about mortality, and Chris mentioned it as well. What we see is that the decline in numbers at age, so this value here is the instantaneous total mortality estimate, is very similar between the habitat types and not significantly different, meaning these lines are basically parallel. That's one thing to note about this. The second thing to note is that these values are incredibly high. Red snapper, the estimated natural mortality is about 0.1. So the total mortality is an order of magnitude higher than the estimates for natural mortality, and this was in the mid-2000s. This is almost the identical value that came out of the stock assessment. If we look at this differently, right, do red snappers stay put, right? So Chris was talking about putting reefs out and having these pair comparisons. For red snapper, that's difficult to do because these are tagged fish and this is their movement distribution. We estimate site fidelity using recaptures that we make on sites where we tagged fish, as well as recaptures reported by fishermen. So on a given reef, the annual site fidelity is 12.8% per year. We hear values such as, we hear qualitative statements such as high versus low. This is a quantitative estimate. I'm not going to tell you whether that's high or low, but this is a fish that can live to be 60, right? Next, we have open season versus closed season mortality rates. So the mean in closed seasons, and again, this is the mid-2000s when fishing mortality was still quite high, we have a Z of 1.31. Closed seasons, we have a Z of 0.08. This is natural mortality, so there's no fishing that's happening then, right? Again, this matches the stock assessment quite nicely. So what are some of the summary and conclusions from this information? First is that there are clear differences in community structure between the two habitats. And Chris mentioned that it's tough to have true controls. I failed to mention earlier that the artificial reefs in this study were had footprints of 10 to hundreds of square meters and vertical relief that was between 1 and 3 meters tall. In the case of the natural habitat, much more expansive habitat, but much lower profile. Next, we don't see any differences in trophic ecology or population dynamics or demographics among the species we examined, so plus or minus. We do have higher densities of some exploited species, right? So that would affect their vulnerability. However, it doesn't necessarily speak to whether we're seeing attraction or production. And one of the issues is that with red snapper in particular, when you put out an artificial reef, because their feeding ecology doesn't differ, they're still feeding off reef on natural bottom, we may be actually providing them access to habitat, to foraging areas they wouldn't have otherwise. So one thing we really need to think about is carrying capacity. I think I'm almost out of time. 5.5 minutes. Oh, good. So I'm almost out of my 15 minutes. So I'll spend a couple minutes here because this isn't easy to digest. So the idea of attraction or production has been proposed. What about attraction and production? So this curve that you see here, this is a surplus production is the type of model. But basically, we have population growth here or fishery yield, right? We can put them on the same axis. So basically, this simple model predicts that at some midpoint of biomass, you have the highest rate of population growth. This is a logistic population growth model. And then over here, we have carrying capacity. So a lot of what we've been talking about, or what's been talked about to this point, are issues related to this term right here, the intrinsic rate of population increase. Do artificial reefs affect recruitment? Do they affect growth rates? Do they affect mortality rates? When in fact, another way to examine this is, have we changed carrying capacity in the system? And a lot of the direct comparison studies, going back to Chris's recommendation, a lot of those direct comparison studies have actually looked at growth and mortality, but have failed to really focus on how have we affected carrying capacity in the system. And so if I were to advocate one approach, in addition to the Bakke design that Chris mentioned, is actually to focus as much here as on the individual population dynamics. And to get back to Kristen Dahl's earlier work where she showed red snapper telemetry, here we have a kernel density plot. This is an artificial reef shown here in red. And the higher, the bluer the color here, the higher their percentage of this red snapper's time it's spent. This is an acoustically tagged fish in the center of that blue dot, right? So the take home is that these fish are spending most of their time within about 100 meters of the reef. However, they don't have high site fidelity. We showed that with the tagging data. But what they're doing is they spend a couple of weeks here and then ping, 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 take a few minutes, and now they're on another reef. And they'll spend 2 or 3 weeks here. And then ping, 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 they end up here. And they spend another few weeks there. So they're staying close to structure, even though they have low site fidelity, getting back to Bonzak's model. It doesn't necessarily mean that artificial reefs are not impacting the overall production by affecting carrying capacity. Because what we're seeing here is out in this open sand substrate, we're now providing them access to perhaps a much larger area from which to forage and derive nutrition. I just wanted to point out that, again, this baseline work has allowed us, I'm not going to get into it, to look at oil spill impacts. And obviously with Kristen's earlier presentation, she indicated how we're using some of the baseline data collected here to examine impacts of lionfish. So we're trying to get as much bang for the state's buck as possible. And then just to wrap up here, several folks to thank. Keith and John have been essential into enabling us to conduct this work. Several folks at National Marine Fisheries Service, other graduate students, charter boat captains. This is all of this work I'm presenting is cooperative research with the fishing community, who are just phenomenal, and their expertise, knowledge, observations, and helping us to gather data to ensure the long-term sustainability of the fishery.
I think we have time for one question, and we'll get the microphone over to you. Does anybody have a question? Oh, one in the back.
Will, can you talk about your thoughts about lionfish impact, given the population numbers you've seen in the red snapper observations that you had recently?
So of the couple thousand now lionfish stomachs we've looked at, we haven't seen red snapper juveniles in their guts. But red snapper don't recruit to these reefs until they're about 250 millimeters. So it's unlikely in these habitats that we would see that. For red snapper, what we're seeing is that, as Kristen pointed out, the indirect effects may be much greater, and that fish are having to go farther to find a meal. They're staying higher in the water column or farther from reefs. That does two things. Energetically, it's costly. It probably implies that they're having less success in finding a meal. And the last thing is that the exposure to predation is probably higher. So those indirect effects are things that we're trying to focus on. In the literature, especially in the Caribbean, you see a lot of the direct effects mentioned on small demersals, but these indirect effects may be just as important in our system with these bigger exploited reef fishes. Vermilion's a different story. Vermilion settles out of the plankton on reef habitat. And we've seen quite a bit of vermilion snapper as a fishery species in lionfish guts. Red snapper, different model altogether, I think.
All right, our last talk before the break is going to be by Bill Lindbergh. He's assured me that he can keep us on time, or the first round is on him tonight. He did. He'll be discussing survival of juvenile gag. I'll go this way.
Thank you. You set me up. Well, Chris and Will set me up pretty well for my talk. They covered a lot of the information that's embedded in what I have to say. I'm going to be focusing on a model system gag, to address what the fisheries implications are for artificial reef development of gag. Is this advancing, Tim? Okay. This is long-term, large-scale work that I don't do by myself. There's a number of collaborators and partners. I'm very grateful for the sponsorship of NOAA Fisheries for the research, and FWC for the reef development that allows the work to go on. I will point out, though, that if you like what I have to say, thank these folks. Yeah. If you don't like what I have to say, blame me. Okay. The approach that I'm taking to the implications of artificial reefs and fisheries management is one where we apply habitat selection theory. Habitat selection theory is well established in the ecological literature. It's well supported across a variety of systems, both terrestrial and marine. It was begun with the Fretwell's ideal free distribution theory here. I'm not going to go through all of these components, but these are just different elements of the theory about how animals choose where to live and why they do it. What I will concentrate on a little bit later is McCall's basin model, because it ties together the behavioral mechanisms and processes at the scale of individual patch reefs and local landscapes with the regional stock and the population dynamics on a broader scale. So I'll try to tie some of that together. The bottom line is that habitat selection balances the fish's risk of natural mortality and their potential for growth. So it's a constant tension that the fish are undertaking in trying to balance these two imperatives. All right. Now, one of the things you'll notice too, Bonsack's contribution to the attraction production question was mentioned yesterday in Steve Bortone's talk. Back in the early 1980s, 83 to 85, the only part of the habitat selection theory that was well developed was the ideal free distribution. The full implications of that didn't come until after Bonsack made his contribution. And in some sense, you might say he was anticipating the implications without having the full benefit of the ecological theory to explain the mechanisms and processes. All right. So that's what we're trying to get at, is that attraction component. That is, why do the fish move to where they do? The model system is gag. You've heard about the stage structured life history, spawning on the shelf edge break in the Big Bend area where I work, settlement in the grass beds. We're concentrating our work on the juvenile stage, ages 1 to 4, that occupy the inner shelf, the shallow shelf, and that's where all of our work has been done. And Chris actually summarized some of the earlier work that gave rise to this expansion or scaling up. And through a series of experiments, we've been able to identify the characteristics of the reefs that the fish actually cue in on as being high quality. What's a good reef to us may not be a good reef to the fish. And one of the conclusions was they're putting a high priority on managing their risk of natural mortality, even if it means they have to sacrifice their growth at higher densities. All right. And there's a lot of other work that's gone in here, but I won't belabor it, except to say that we have an experimental foundation for making a contrast between relatively higher and relatively lower quality habitat from the perspective of the fish. All right, and that's going to become important as we get into the actual data. Now, building on those earlier experiments, we expanded this with the concept of a management area. What if we took a large area and peppered it with a large number of the kinds of reefs that previously were demonstrated to provide higher growth rates and lower fishing mortality rates, all right, and presumably or possibly lower natural mortality rates. And so we have 100 square miles off of Steenhatchee that was permitted for exactly this kind of work. The Swanee Regional Reef System, in which most of the experiments were conducted, is here. We constructed in 2005 a line of evaluation reefs that bracket the Big Bend as monitoring stations, and then monitored those to develop the baseline before the Steenhatchee Fisheries Management Area was constructed. Here's something of a timeline, but it does point out how long-term this is when you try to scale up to what may be a regional fisheries scale. Conceived in 1998, and the evaluation of the treatment really didn't begin until 2013. In 2011? 2011, we were able to place within a 3-week period virtually all of the conservation reefs within the management area, 500 reefs within that 100 square miles. So the evaluation plan calls for continuing to monitor the abundance and size distribution of gag here, continue to monitor selected stations in the Swanee Regional Reef System, and then doing tagging and sampling inside the area and areas that were undeveloped adjacent to it. All right? And the tasks involve non-lethal sampling for size and age of the fish, tagging of the fish, an effort to estimate the growth, the total mortality, and see if the assumptions are valid to allow some estimate of natural mortality. If the fish are behaving so as to reduce their risk of natural mortality, we need to be able to measure natural mortality, but that's the hardest of the demographic parameters to actually get an empirical measurement of. All right, so that's really difficult. And then the goal would be to feed those demographic rates into a spatially explicit population model to see how it scales up, with the question of, if we are able to tweak the system to get better survival and better growth of those juvenile life history stages, how much would you have to develop in order to even see any impact or consequence at the scale of a regional stock? Or is it merely a drop in the bucket that has no a signature that we can't detect? Now, McCall's Basin model is a mathematical, spatially explicit population model. But fortunately, he gave us a good visual representation. That's why it's called a basin model. You can envision habitat quality as being analogous to the depth of a lake or a basin. All right, so this would be the highest quality habitat. I'm not saying the deepest water is the best habitat. I'm saying, just as an analogy, right? Lowest quality habitat might be up here, and the lake level, you can think of it as the population size, the size of the stock. In the mathematical model, it's actually R, that intrinsic rate of increase that Will referred to. But for our purposes, just think of it as population size. And when you do that, you start to realize that there's some predictions that come from thinking about how fish distribute among the habitat of differing quality as stock levels change. So as a population decreases, you should always find the fish occupying the highest quality habitat. As the population decreases, the lowest quality habitat should not even be occupied, and the intermediate habitat should change at a faster rate of decline than the higher quality habitat. Conversely, when a stock starts to rebuild, The higher quality habitat should start to increase first, and then the lower quality habitat accumulate fish as the spillover into the lower quality habitat occurs. It's just basic logic as to what you would expect the fish to do in their own self-interest. So that led us to a number of predictions, and the events of the past decade actually gave us a good opportunity to make an experimental test of those predictions. In that, here's the stock assessment model from the 2014 GAG stock assessment. Right, the red lines show the time frame that I'll be showing you from 2001 to 2013. But here's the red tide mortality event that we're all familiar with in the eastern Gulf of Mexico. Right, that radical change in stock status, stock abundance, gave us the ability to compare the predicted trends between the higher and lower quality habitat. Now on the right here, you have some of the largest year classes of age 0 GAG that have ever been recorded, and that's in the assessment model. That's what's driving this quick recovery in the condition of the stock. All right, so just to get you oriented, this will be about the only data slide that I show. Right? This is on a log scale, all right? Not actual numbers, it's on a log scale. So this value right here, this average value, is about 46 fish per patch reef, 46 GAG per patch reef. This is about 21, this is 7. All right, so the log scale distorts the trends. It's actually more severe than what it appears on the graph. The green lines are the higher quality reefs from the Suwannee Regional Reef System as defined by the GAG themselves, according to their own preferences. The blue line are the relatively lower quality reefs in the same system, again, as defined by the fish. And you'll notice that while there was a drop in numbers here, there's no trend over time, despite the fact that the stock went through a radical crash following the red tide event in 2005. That higher quality habitat was always occupied at a very high level. And this creates a condition that's very vulnerable to what we call hyperstability in the catch per unit effort. It's conceivable, in fact, this is the exact kind of situation in which you can see your catch rate on a reef system remain high, even though the change in the stock is going down, and you don't even see it because your reef is continuing to have a fish occupying. There's a significant difference between the trend following that red tide event between the higher and lower quality habitat. Now the red line comes from these offshore reefs, which were constructed in 2005. We started monitoring in 2007. It takes about 4 years for the colonization of new reefs to reach their saturation point. And you notice that the reefs that were offshore are of exactly the same habitat quality or design as the lower quality habitats in the inshore reef system. And once they reach that saturation point, it's almost like they're at that ideal free equilibrium distribution. It's what you would expect from the ecological theory. There's no difference between the inshore and offshore reefs in the abundance of GAG. But then in 2011, when the bulk of the 500 reefs within the Steinhatchee Fisheries Management Area were constructed, you notice that in the following years, there appears to be the beginnings of a recovery here, even though there's a lot of variability among the replicate patch reefs in the inshore reefs here. But these offshore reefs that were adjacent to this area that was just constructed showed a significant decline. It's what appears to be a shadow effect of having created an abundance of habitat inshore. That's the area that's transited by those juvenile GAG during that life history stage. This is, to me, is a representation of the redistribution that can occur over a regional scale when you're dealing with fish that move from patch reef to patch reef to patch reef. Now, Will talked about red snapper moving on the frequency of weeks. Gag actually have a site fidelity where they'll stay resident on a reef for upwards of a year, or a little bit more than that if it's a high quality, a little bit lower than that if it's a low quality reef. But they're hopscotching across that broad shelf. And we would expect that this difference here should diminish over time as the system re-equilibrates to the new distribution of reef habitat that's available in the region. All right. So with the attraction production question, we're not really talking about an either or. We have an understanding of how the fish are moving, and that attraction is an expression of their adaptive natural behavior. Right? But it has implications for how we perceive the abundance of the fish, whether we're looking at reefs that by design are perceived by the fish as higher quality and therefore maintaining a high standing stock at the location of the reef, regardless of what's happening on to the regional stock. So we had some technical difficulties. The video won't play for you. You don't get to see 150 gag on a 4 yard square patch reef, but based on our work to date, the recommendations that I would make is that clearly we can consider artificial reefs part of the economic infrastructure for the coastal communities. That's unequivocal. The user benefits, the economic activity that's generated and so forth. It may be possible for selected species to increase by an increment the amount of a strong year class that actually joins the spawning aggregation. Right? But that's not yet demonstrated. Right? If there's a bottleneck in the population, then we may be able to alleviate that. Well, one of the things that has come from this work is that given the significance of habitat quality to the variability in fish abundance at given locations, there is the possibility of standardizing habitat quality through standardized reefs and improving the precision of fisheries independent indices of abundance that add more information into the stock assessment processes. So that may be an unanticipated way that artificial reef development around the state could contribute to fisheries management, not by virtue of its habitat, but by virtue of controlling something that actually adds a great deal of variability to the data that goes into our stock assessments. So with that, I'll take any questions if we have time.
Questions?
Do we have time? Okay, yeah, we'll take a couple of questions, but remember, Bill's going to be on the panel here just after the break. So if you have any more questions, you can.
No, it won't.
You're not? I thought you were up there.
No.
No? Okay. If you have any questions now, better ask now.
Bill, Bill, I have one question. And I've brought this up several times. We're talking about fish management. And when we go to these council meetings with the South Marine Fishery Councils or whoever it may be, we talk about artificial reefs, if they include them in their fish management plan. And they say no. But we're talking now about fish management.
Well, this sounds like an Andy question. Yeah, Andy Strelchuk will be on the panel, but yeah, my understanding is that the contribution of artificial reefs to the general fisheries is part of the fisheries dependent data. Whether it's commercial catch or the recreational catch, they don't record where the fish were caught. Right. So, that information is going into it. Yeah. I'll let Andy answer that one.
Any other questions for Bill? Bill Seaman.
Benadryl helps.
Brian just said make it a hard one.
Oh.
I'll ask about your point number 3, where you say improve the precision of fishery independent indices. Could you elaborate on that? That's pretty interesting. How would you do that?
Well, do I have time to run back to? Okay. Now, this was done with a Bayesian negative binomial hierarchical model for those eggheads in the audience. All right. But basically, by controlling habitat quality, you're controlling one major source of variability when we go out to count fish and try to estimate the abundance of fish in a relative index of abundance. So if the relative index of abundance is to monitor trends over time, if you can control that habitat quality, you narrow the error bars. Now, what's more interesting than that is the contrast between higher and lower quality habitat, because you would expect to see the lower quality habitat diverge from the higher quality habitat in a declining stock. So it's a way of detecting a change in stock status given the way the fish distribute themselves among the available habitats that differ in their quality. But that's harder to do on natural habitat than it is with controlled units. But you have to know what the fish perceive as being higher and lower quality habitat. So gag may be eligible for this, perhaps red snapper, but you couldn't do this for all fish. Did that answer your question, Bill?
Okay, this closes out our session. We'll be back here at 2:45 for the panel. And don't forget that we're going to have the drawing for the wetsuit. So if you haven't dropped your business card in there, go ahead and do it. Heard the water temperature was 58 degrees on the bottom. So yeah, this is something you definitely need, right?
One. Check, check, check. One, one. Two, two. Check. Thanks, Tim. Three, three. Check. I did. Check. Four, four. Five, five. One. Check, check. Six. Check. Seven. Check. Eight, eight. Check, check.
at. Where are you based out of?
Lee County,
Okay,
Fort Myers.
so you're not that far because it's in Hallandale over in
Oh,
Broward.
yeah,
So you just
yeah.
cross the alley to get it.
Testing 1, 2, testing. Michael Barnett, can you hear me? Okay, just making sure. Sorry, you're the only one I can see whose name I know. I'm testing the mic. Sound good? Yeah.
you turn on 13? Yeah, I'm gonna make an announcement about.
Yeah.
So, guys, we're gonna get started in a few minutes. So I've got more door prizes. First one I have is a Kelty backpack with a built-in little camel pack in it. So Shelly Marshall. Oh, you look like a Shelly. Yes. Next we've got a Sea Grant hat, Eternal Reefs. Sea Grant shirt, Eternal Reefs hat, and the VividPix software. Oh, where we got him. Steve Bartone. All right. Zach, talk to Chuck Adams. He'll get him. Next, arc dehooking tool and Eternal Reefs hat. Robin Springer. Robin here. Tammy Taboo from Core. All right, you got that. And then finally, we have a Reef Innovations hat, a UF Dive Program shirt, and a reef ball. And if you don't want the UF shirt, I will take it from you. Alexandra Carvalho. Alexandra. Oh, all right, cool. Thanks, guys.
The long sleeve. Got the dive boat on the back. Yeah, go for it.
Okay, hold on. Can everybody hear me in the back? I have a wireless mic, so we want to make sure we're testing. It sounds good to me. So we're in the last session of the day, and we've spent the last day and a half hearing all sorts of presentations that address our guiding questions. And what I want to ask of everybody who has the booklet still is to open up to that last page in the booklet so you can refer to those guiding questions again that we've been discussing again throughout the presentations we've heard. So guiding questions: what's the natural ecosystem and how will the artificial reefs interact with this ecosystem? Who are your stakeholders? And I want to remind you the sort of basic definition of stakeholders: those who can affect a decision, those who can be affected by a decision, and those who have knowledge that's necessary. A fourth stakeholder in this case might actually be those who aren't directly engaged with the artificial reefs, but Florida is a unique place in that non-anglers are often really engaged in fisheries issues. Plus, it's the natural systems. What are the objectives of the artificial reef you're building, and what led you to the design and construction of your reefs? How is monitoring and evaluation designed and conducted to ensure you are meeting your program objectives? And how are reefs being used? And how are you determining their performance? Okay, so that's the guiding questions we've been talking about. And each presenter has done maybe a few of the different aspects of artificial reef development. What we're doing for this afternoon is we want to discuss the inherent tensions that might exist between all of the different objectives of the reef system, between the users, between the natural system and the man-made systems. And as such, we've invited 8 panelists, I had to just do the math, from different perspectives, and they've had a conference call and done some discussing about what their perspectives are, but we're gonna do a Q&A session with you all. So you know who we are. You have 3 moderators today. My name's Joy Hazel. I'm the Lee County Sea Grant agent. We have Holly Beals, who's the Brevard County Sea Grant agent, and obviously got the memo on the color choices of clothing today. And in the back, we have Brian Flick. Yeah, he didn't get the memo. And so we're going to be moderating the panel. Our job is essentially traffic control. So we're going to make sure that the questions stay on track with those guiding questions, that we are tough on the issues, easy on the people, that we really respect the panelists' time and make sure that they all get a chance to contribute to the discussion, and that we do, to the best of our ability within 2 hours, examine all of the different aspects of artificial reef design, construction, and management. Okay? So as such, there may be times, maybe we spend a lot of time on, we've obviously talked a lot about the ecological considerations. There may be a point where we get really far into ecological considerations where I may ask for a question more about objectives or about your stakeholders, just to make sure we touch on all the different tensions and issues. Any questions about that? Or what the next 2 hours is going to look like? So if you have a question for the panel, raise your hand, and Holly or Brian, well, I'm going to start with actually I have an initial question. But Holly or Brian will come around with a mic, and we'll ask you to stand up and speak into the mic so everybody can hear the question. Okay, am I missing anything? Oh, well, that I know, yeah. Okay, so what we're going to do is I'm going to first just have the panelists run down, and if you'll notice, we don't have name tags, but we put them in the order that they're in the booklet, so you can remember their names as we go through if you don't know them. But they are going to introduce themselves and tell you their affiliation, and I'm going to remind you to turn your mic on when it gets to you.
Well, good afternoon, everybody. Can you hear me okay? Yes. Okay, there we go. Good afternoon, everybody. My name is Luis Barbieri. I am a fisheries biologist, and I work for FWC's Fishing and Wildlife Research Institute. I'm centered out of St. Pete, and I head our statewide marine fisheries research program.
My name's Andy Strelchek. I work for the National Marine Fisheries Service in St. Petersburg, Florida. My former life, I conducted research on artificial reefs. Nowadays, I'm a fisheries policy analyst and oversee a lot of the analytical duties related to Fishery Management Council decisions.
I'm Robert Turpin. I'm a marine biologist and the manager of Escambia County's Artificial Reef Program and Waterways Management.
I'm Pat Quinn. I'm with Broward County's Marine Resources section, and I guess by process of elimination, and the Artificial Reef Coordinator.
Good afternoon. I'm Don Roberts, a volunteer with CCA's Florida, the Coastal Conservation Association.
I'm Jessica Kelsch, and I'm with National Wildlife Federation. I am from here. However, I'm currently in Pensacola, Florida. National Wildlife Federation, you guys may know us from Ranger Rick magazine, but our members are a lot of sportsmen, anglers, and hunters, but also wildlife enthusiasts, bird watchers, butterfly gardeners, a really broad spectrum. So I represent a broad range of views. And my kind of area of specialty is looking at how the oil spill funds are put back into projects.
I'm David Walter, and I own the Reef Maker in Orange Beach, Alabama. And we're somewhere close to 40,000 reef deployments for Walter Marine. And you guys watch your eyes just a minute. Robert, I have to do this. We actually have the biggest snapper in the Gulf of Mexico. And I also have to tell Dr. Bartone, who I'm fond of, but he poked a little fun in Alabama about our automobiles. And I have to tell you that we've done quite a bit of research, and we have discovered that Buicks float longer than any other car.
I'm Todd Barber. I'm chairman of the Reef Ball Foundation, where I'm currently living in Sarasota, Florida.
So as you can see, we have lots of different perspectives. So I'm going to open the panel with the first question, and I'm going to ask you all, from the perspective of the stakeholder that you represent, what is the primary objective for the construction and management of artificial reefs? And we'll just, why don't, yeah, we'll actually go this way because I did tell them. I'm not sure if I told you.
So going to that first question, right? Do I read it? Do I read it or just?
No, what is the primary objective of an artificial reef program?
From the perspective of my program, yes. Well, I think the primary objective is really in terms of increasing fishing opportunities, perhaps enhancing habitat, right? And in my case, because I do research and monitoring, is really sort of interacting with the reefs and how they impact abundance and distribution of fish out there. So there are a number of studies that we conduct and a lot of data that we collect that is used in support of stock assessments and a lot of other analytical approaches that impact fisheries management and impacts the way that fisheries are prosecuted out there. So for us, it's understanding, and we saw some of the talks this afternoon and some of the issues that were discussed, really, how do those structures perhaps impact the ecosystem, the ecology of the system? How do they impact the distribution and abundance and biological processes that naturally take place in terms of migration, feeding, spawning, natural mortality, and all of those things? And how do we take those into account as we assess the status of populations, fisheries populations out there, and their ecosystem as a whole? So that would be my perspective into this.
From a federal perspective, I think there's a lot of similarities between what Louise said and what I would say. From the federal government managing a lot of these exploited reef fishes that Will spoke about, as well as the other many species that we manage, the key, obviously, in fishery management process, whether the state or federal level, is controlling for fishing mortality, ensuring that populations are maintained at healthy levels of abundance. If they're depleted, we have very stringent mandates for rebuilding those populations and improving their health and status. As that relates to artificial reefs, it's key for us to obviously understand how do artificial reefs affect fishing pressure, fishing mortality on these very heavily exploited species. How does artificial reefs change the distribution and abundance of the population, and how does that then affect research and stock assessments that we conduct that help to monitor and review the health and status of those populations? And then ultimately, what a lot of the speakers spoke about today really gets back to this attraction production debate is, can artificial reefs supplement or bolster the population carrying capacity? And if so, how is that then accounted for and integrated into our assessments and ultimately accounted for in management? If in fact carrying capacity is being increased over time because of the addition of habitat, then that should be reflective of data and information that would indicate that the population is larger and therefore yields could be increased. If it's attraction, if it's increasing fishing mortality, then obviously it would have a negative effect on fisheries management. So it's really trying to strike that balance between the two in managing our resources.
From the county reef manager perspective, I've got it down to pretty much one sentence, and I'll read it to make sure I get it right. It's to maximize the sustainable access and economics of the consumptive and the non-consumptive users of marine resources, and that includes residents and our tourists. And I do that through four broad categories of listening to the stakeholders, listening to the folks that I'm serving, planning, which includes permitting and getting funding, acting, which is the actual deployment, but then going back and measuring through monitoring.
I'll take one word out of his sentence: economics. So what it boils down to in Broward.
CCA we're a 501c3 corporation, and we're about 10,000 members in the state, 100,000 nationally. What we're all about is protecting the resource, recreational angler access to the resource, and for us, the third leg of that is habitat, both offshore as far as reefs and then inshore habitat as well. So this fits very well with our overall objective of protecting the resource and angler access to it.
As the Wildlife Federation, just to build off a couple of the words Robert mentioned, non-consumptive use, Don mentioned habitat, and I think that is where we're primarily interested, is that we see we're focused on habitat restoration, and we see estuaries as really being at the heart of that. Artificial reefs, a lot of time, not necessarily in this audience, but I think the general public, the media, the general fishing community, that they think of artificial reefs and they think of a fishery management tool. Artificial reefs are much broader, and they include, I mean, we've heard of a couple different types, the near shore and the inshore, as well as those offshore reefs, but even oyster reefs, and would really like to see more emphasis put on artificial reefs as not just a place to go and fish, and this whole production versus I'm sorry, the word just escaped me, attraction, but just, hey, let's look at artificial reefs as a tool to really help build fish populations as nursery habitats. Look more at it as the front end of helping the fish species, not just the back end, a place to go and catch fish.
As a contractor, I have a different perspective, of course. Alabama has the only real true private artificial reef program. And when we first started building reefs, we had literally thousands of people giving us feedback on what worked, what didn't work, how it worked. So we focus our interest on, what do you want to do with the reef? Do you want to attract a certain species? Do you want to attract juvenile fish? Do you want to grow oysters? We want a reef that will be stable, not turn over, not sink, last a long time. A reef that's big enough where a 30-passenger charter boat can pull up on there and everybody catch fish. Those sort of things is what we focus on.
At the Reef Ball Foundation, we kind of think about what's happening in this world. And what's happening is that we're losing our reefs. We all love reefs. So everybody that's in this room is here because we love the ocean and we love the reef. The reef is a habitat, and our job is to put that back. We have to put that back in any way that we can put it back that's as close to the natural system that we can. So we focused on that, trying to make artificial reefs as close as we can to natural reefs. The closer we can get them to natural reefs, the more likely they're going to function correctly. And that's what we're here for. We want to put back what humans have kind of taken away from nature.
Okay, so we're going to open the floor to questions, and I see one here, and I see one here. What I'm going to do my best to do is stack you guys and let you know that I've seen you. One,
Hi, I'm Brian Clark with Coast Watch Alliance. There seem to be a vast number of unpermitted man-made objects out there along with our permitted artificial reefs. I was just wondering what the panelists think about, and not everybody needs to answer if they don't feel so moved, but are they good? Are they bad? And should we as a society continue to turn a blind eye to this kind of activity where folks are dumping materials out there that are not permitted?
you'd like to?
And I've seen a lot of this stuff, and many of these objects were placed in years prior to the regulatory work that's been done over the last several decades, and that are still there. And a number of these materials would be permissible under the materials guidelines, but they're put in unpermitted locations. So I guess that if it causes problems, then anything that causes problems should be addressed. And then if there are things that we can do in our artificial reef programs to provide a disincentive towards that activity, then I think that that would be part of our mission as well.
Anybody else want to add anything in?
Well, that's something, like I mentioned before, anything that extraneous, right, to that ecosystem and doesn't really belong there in that way that was deployed. I mean, what's the impact on the ecosystem? What's the impact on the biological processes that take place? And, is it impacting negatively what's already there and our ability to measure all of this? I mean, Chris's talk earlier today, and I guess Will's as well, mentioned the uncertainties that are associated with trying to evaluate what's going on in marine systems, right, and monitor and study marine systems. And the more that we add noise, so to speak, by throwing in there things that don't belong and will be disruptive to the system, the more we're gonna harm our ability to come up with answers that are really close to how those systems function. And there's also the issue, and we deal with this statewide more in the Florida Keys now, with the impact of, some, in the Florida Keys, in this example that I'm thinking about is really fish traps, right? Lobster traps and fish traps, and how they, depending on ocean conditions and wind conditions, can actually move and impact natural habitat and actually be destructive to the natural reef that has been there for millennia. So that would be my perspective of how those things could be harmful to the process that is trying to be accomplished.
Yeah, my knee-jerk reaction was it's litter. It's trash. It doesn't belong there. I'd be very interested to hear what Todd from the Reef Ball Foundation says, since he's just was talking about the importance of replacing the natural systems that we're losing, and it's not natural. And again, I think it again puts the focus on harvest, not habitat. In my former life, I worked for Ocean Conservancy, and I did a lot of debris removal and derelict traps. And sometimes we'd get a crab trap, and it'd be so encrusted with oysters that it had become habitat. And so, with the case of getting debris out of the environment, in some places it's not appropriate. It's there, maybe leave it there if it's already been incorporated into the system, but that doesn't excuse it. And I think it's trash. And if you talk to people or hear people that do them, then I think you should shame them royally.
Todd, did you want to?
Yeah, I would have to say it depends. When you're putting something in the ocean, the question is, are you replacing something that was lost because something we did wrong? Did we destroy a reef? And sometimes putting a chunk of, I don't know, let's say limestone boulder in the same place where it used to be and allowing nature to take over and do its thing can be a good thing. As we've heard down the panel, if you're putting a trap in and it's just going to kill marine life, that's not very good. So it really becomes a thinking job. We have to think about everything we put in the ocean. Is it trash or is it habitat? Best way I can explain it.
I'd like to say, we draw these lines in the sand out there, and they say this is where you need to put the artificial reefs. And if you put the same artificial reef outside the line, that doesn't necessarily make it trash. It's still habitat. It's a man-made line. But if it interferes with poor guy with a shrimp boat, and he's barely making it, and he gets it caught in his net, and it tears his net up, and then it moves it so the guy that put it out there, he can't find it anymore, then yeah, it's a problem. And we don't need those kind of problems. They just reflect negatively on the reef program.
Yeah, I think a lot of times the difference between an artificial reef and trash is merely a permit. There were some guys in Broward a few months ago. They were loading up a whole bunch of cinder block on a boat, driving out. Well, you can't bury a body in Broward County without somebody seeing you. So it was only a matter of 5 minutes before FWC was out there going, "What you boys doing?" And dumping all the cinder blocks. Well, guess what? Now you have to take them all out because they didn't have a permit to do it. Broward County wanted to dump a whole bunch of cinder blocks down there. We'd file for the permit, get a notice general. $250 later, we're dumping cinder blocks out there. The problem we have with Broward, and Steve brought up an interesting point too about Nova's putting in these artificial reefs, but not necessarily Nova. I don't want to pick on Nova, particularly since my degree came from there. But we're putting the artificial reefs on the sand flats between these natural reefs, the coral reefs that we have out there. And it's a pretty big sand area, but not near what the rest of the state has. So we have a very limited area to put them in there. So it's really important that we make sure that these reefs are going to be stable. We can't go 35 miles offshore. If we're 3 miles offshore, we're in over 100 feet of water, 200 feet of water. You talk about these 35, 40-minute boat rides, we're in 900, 1,000 feet of water. We have no continental shelf to speak of. And so it's really important that we make sure that anything that we put down there is going to be stable, be it reef balls, be it a ship, be it a pile of cinder blocks. Y'all saw the picture that Sarah had in her presentation about the tire reef that's out there. That picture was taken at 70 feet of water. And for the most part, the tires down there are relatively stable. But enough of those tires have washed over the reefs, and they are now in 20, 25 feet of water. You go out there on a relatively benign day, seas are 2 to 4 like they always are in the summer, and you just see the tires moving back and forth on top of the reef. And so at that point, yeah, it does become a serious issue. So if somebody's just dumping something out there because they want to build their own artificial reef, no, unless it's really gone through a vetting process, particularly in Broward County, because of how close the natural resources are, then yeah, it definitely needs to be removed. Even if it's been out there for a while and it's starting to colonize, unless we can ensure that it's going to stay safe and not wash up and kill corals that are hundreds of years old and struggling to survive, then I think it would be our opinion down in the southeast part of Florida, they would have to be removed.
I'm going to move on. We've got 3 questions that I know of.
Yes.
4.
As I was listening to the different speakers yesterday afternoon that are actually building artificial reefs, perhaps they were working for, they were representing all the counties of Florida, I heard something in every single one of their presentation, and that was that one of their biggest problems was permitting issues. And what I have noticed when I go to artificial reef summits and workshops is that's an issue that continues to be repeated, but I'm not hearing anything about how we can improve the system. We have on this panel Mr. David Walters from Alabama, and I've looked at the Alabama permit areas, and I was wondering if perhaps he could tell us a little bit how Alabama works their permitting areas, and perhaps how Florida could improve our permitting to help us build our artificial reefs in a faster process.
Well, I can't speak to how you could do it in Florida, but I'll tell you how we do it in Alabama. The Conservation Department is right there in Gulf Shores. We only have 30 miles of coastline, so we don't have a large area, and really only take that about half for where the reefs are deployed, only out of 2 passes there. And I can call the Conservation Department today. They will come over and look at the reef material, and if it's suitable and clean and meets their specifications, I give them $25. They give me a permit, and tomorrow I can take it out and put it in the artificial reef zone. I don't have to tell them exactly where I put it. They want to know close, but I don't have to tell them exactly. They do not go out and check to make sure it's there. We find if a private fisherman is going to pay $2,000 for a reef, he doesn't want somebody going out and anchoring on the reef and going down and making sure it's there while everybody else rides up and writes down the GPS coordinates. So Alabama does protect that very well, and it's a good system. Of course, with the our private reef program is falling off considerably with 9 days season and 2 fish, and we only have a 3-mile boundary for Alabama. But that's how we do it in Alabama.
Underwater permitting, not permitting for a deployment.
Oh,
your big permit areas.
Well, those were done many years ago, and Alabama's artificial reef zone was done in perpetuity. They if I'm saying that word right, the permits were issued, and they can never be rescinded by the Corps. They belong to the state of Alabama, and they're permanent.
I know Robert wanted to.
Yeah, and one of the issues that comes through the permitting process is that we have, if it's in state waters, and that's generally where I think most of our attention is going, is that you have a permit from the Florida Department of Environmental Protection and you have an Army Corps permit. And these get out of sequence. And then when we're, as county managers, as we're applying for grant funds, if we don't have active permits, then we're prohibited from getting grants from the state. So when you have these offsetting and when you have permits that are in renewal for long periods of time, it can take you out of the running for artificial reef construction grants. So we have a good, I think, a good relationship with the permitting agencies. And now we're working on, instead of going from the 5-year to 5-year permits, now we're looking at 10-year permits and longer, so that we reduce that overlapping renewal stuff. So we just need to work with the permitting agencies and see what is the maximum time that these permits can be issued for, and work towards that.
I think Holly.
Is this guy? I thought he was next.
He had his question answered.
Oh, okay. Howdy. Considering that the thousands of oil platforms in the Gulf of Mexico have unwittingly come to serve as the world's largest artificial reefing system, and seeing the alarming number of removals of the platforms due to the idle iron policy, why is there no plan in place to mitigate the loss of this essential fish habitat?
I can't speak from the standpoint of the agency that's responsible for permitting the removal of the oil and gas platforms. My experience with the Fishery Management Council and NOAA Fisheries Service is that we've made many attempts to work with oil and gas industry to make recommendations, express our concerns in terms of the removal of platforms, how they're removed, and try to minimize the impacts associated with the removal on the marine resources that we manage. With species as critical as red snapper that are rebuilding, some of the steps we've taken is to include mortality, or look at the inclusion of mortality from oil and gas removals into our stock assessments to see what impact that has in terms of changing the biomass abundance, fishing mortality, or total mortality of the species itself. And so we have looked at it and accounted for it. I think what it'll take is some additional collaboration across numerous federal government agencies, and there's certainly an immense cost with removing these platforms and trying to figure out a way to balance the ecological objectives that we have at the Fisheries Service with the economic cost associated with the removal of those platforms, and trying to minimize that while minimizing the impacts on marine resources. It's not an easy solution, and we've worked toward coordinating with the oil and gas industry and federal government agency responsible for regulating them. And steps have been taken to move forward with that, but unsuccessful up to this point.
Brian?
My name is Charlie Fonachari. I'm the project manager for Dixie County. My question, I'd like to direct it at least first to Robert. Robert, the monitoring methods that you use or prefer, can you describe them?
Sure. Excuse me. We do during the construction, we're having to monitor the reefs to make sure that they go down in the right place, and then they occupy the appropriate depth once they're on the seafloor, and those are construction phase monitoring. As soon as possible after the construction is completed, we dive the reefs and visually inspect them to assure permit compliance. And then also that feedback information helps us gauge our abilities to construct the next artificial reefs. And then once they're on the seabed, we do fathometer monitoring to make sure that they're in their location on an annual or ongoing basis. And then we take a subset of those reefs, and then we dive those and look at their physical performance, the deterioration over time, their amount of subsidence. We look at the biological community. Typically, the biologicals we're important, or that are important to us, are the abundance of the species that are recreationally and commercially exploited. And then we're also looking for threatened and endangered species. And we're also looking for now lionfish.
Anybody else want to address that question? Okay, Brian.
We've learned recently about the addition of approximately 4,000 to 5,000 reefs in the northern Gulf of Mexico off of Florida Panhandle. I was curious about what the panel was thinking about. What are your thoughts about setting up a before-after control impact type study, or implementing monitoring for this very, very large expansion of artificial reefs in the area?
Well, short answer is yeah. I mean, that would be a great idea. I mean, to me, this is a concern, in terms of what will be the impacts of all of these new structures on our ability to measure population trends over time for some of those exploited species. Not to get too deep into that production attraction debate, but if there is a component there of attraction from natural reefs or from other non-reef areas to artificial reefs, we're going to have a disproportionate distribution there of different species and different age classes. And it's going to be difficult for us conducting the surveys that we conduct and try to evaluate population trends to inform stock assessments, to take that into account. It's like a curveball coming from the side, and it might influence, it may not have any impact at all, but it might influence our ability to measure in a system that's already very noisy. So I think that anything that can be done to evaluate really what's really going on in this new 5,000 structures, and at least documenting what are the species that colonize them, and what are the size and age compositions of those fish that gather there. And then if there are any biological processes taking place, like spawning in some of these areas, that we can have that documented, so we can integrate more of that information into the stock assessment process.
The first NERDA proposal for funding for artificial reefs, I wrote that in 2011. And in that first design, I actually took an experimental design approach to deploying those artificial reefs as patch reefs, and actually sent them to Dr. Bortone and discussed it with Florida Fish and Wildlife folks, John and Bill and Keith, and that was taken into account. I think it's important for everyone to understand that those negotiations for those NERDA projects were taken on by the state of Florida as our trustees. So Department of Environmental Protection took those, negotiated those with BP, and then for the artificial reefs, they did what they absolutely we hoped that they would do. They brought it to FWC's artificial reef program and said, you guys have the expertise. So we'll have that oversight. We'll be using our existing permits. And I've talked with Will and some others today about how are we going to place those reefs so that we have good experimental design and we don't lose this opportunity. This may be a once in a lifetime opportunity for us to deploy artificial reefs that can reduce that noise to the greatest extent possible and use this as a learning opportunity, as well as to restore human use and also habitat.
I'd like to ask Jessica and Dawn to respond to that question too, with your work with NERDA and then as a representing stakeholders. Sorry to sort of throw that on you, but.
My brain was just kind of listening to what Robert was saying. And the original question was actually, how does all these reefs fit together? We have all these reefs that are coming forth out of the NERDA process. There are a lot of other BP funds that are going to be available through something called the Restore Act. And artificial reefs are an eligible activity for that. Under the Restore Act, you can do things to improve the economy, improve tourism, improve the environment. And I think artificial reefs are, like I said, they definitely fit as an eligible activity because of the economic benefits, because of the tourism draws, and to some degree the environmental benefits as well. But I don't think those artificial reefs should be done just as a environmental benefit, because I think the other benefits are just as much, if not more, substantial. However, I think it's important to take a holistic approach and not for individual counties to say, hey, I want to do artificial reefs here and I want to do them there. And I think that they need to be coordinating very closely with the FWC. I think Florida is very fortunate that they have such an artificial reef program through the Fish and Wildlife Conservation Commission, and everything needs to be done comprehensively and complementary, and not individual counties kind of coming up with their own ideas and going off in one direction and not being part of the larger package.
I would see our organization kind of as a support group. I mean, as you got trying to monitor these things, one of the things we bring to the table are volunteers that like being out on the water and enjoying that sort of thing. So if we can help them from the monitoring side, I think what everybody said as far as the holistic approach makes a lot of sense. But part of it gets down to the actual nuts and bolts of people diving, monitoring the sites and that sort of thing. And I think that's one of the things that we help bring to the table is the manpower to help do that in the various counties that we have around the state.
Yes, and thanks for reminding me that in that funding source, there are designated funds for monitoring.
I'm Jay Leveroni with Sarasota Bay Estuary Program, and I guess my my question was inspired by Bill Lindbergh's talk earlier, but it kind of segues into this discussion of monitoring and evaluating the artificial reefs. And I know we've come a long way in the types of materials and the development of reef materials, and some now are somewhat the standard for at least some applications, like the reef ball is a good example of that. And so my question or my comment to hear from this panel and others is, I think artificial reef development and practices are now at that point whereby we are starting to know what types of materials, or more particularly, what type of modules are best suited for certain types of artificial reef. And let's look at fisheries habitat, for instance. And I know we put a lot of stuff out there that it's extremely difficult in and of itself to evaluate certain types of things, let alone compare some artificial reef with another one when the construction is entirely different. So I'd like to hear the panel's discussion, especially in lieu of the opportunity that many counties in the state are going to be deploying lots of reefs. If there's a consideration for trying to be in some way consistently using those types of modules that at least show the best promise for these things, and trying to develop some kind of consistent plan so that people are putting out more similar types, or actually specifically similar modules, if you will, so that we learn the ability to evaluate them will certainly improve, and we will learn a lot more because we're using similar types of materials. So the question is basically to address the types of materials we're putting out to benefit the science and the opportunities to either fish or dive on them as well. Thanks.
I think maybe I could address that a little bit. David and I have been in an industry that's designed artificial reefs for the last 20 years. They've been through all the monitoring, they've been through the tests, and they work. And pretty much you can pick any of our materials and guarantee you're not going to cause any problems. Now, if I'm putting it on an oil platform, maybe not. Maybe it might work in some places, maybe another. Doesn't mean that's not the right thing to do. We need to experiment, we need to monitor, we need to keep getting better. And what we do is getting better. But particularly in situations where you're talking about where a lot of stuff's got to go down quickly, It's way better to go with something that we've known for years and years and years works and keeps working. The closer you get to mimicking the natural reef, the more likely you don't have to worry so much about it. The closer you get to something different, if I put a chicken coop down in the water, well, fish is going to come there, but there might be some problems with it. If I put something down that's been designed specifically to create nothing more than a coral reef, more than likely it's going to do better. So I'm not judging any type of material. I think all types of material have good reasons. There's great reasons to use, as I think Jessica said, we got to think about what humans want, what humans need. There are reasons to put stuff where we're going to get benefits from that, but there's also reasons to just, if you're not going to have permit, I mean, we do stuff around the world. A lot of places don't require permits. People come to me and say, oh, I'm going to throw something in the water. I'm like, well, okay, if you're not going to study it, you're not going to look at the bottom, here's something that will do less harm. And I don't know, that's sort of the way you need to think about it, is the range of materials. Some can have a high consequence of bad things happening. Some have a lower. And design reefs typically have been designed to minimize those kind of problems.
And Pat, and then Andy. Sorry.
Yeah, and most of the talks, I saw a couple of posters that kind of address this. Most of the talks here are dealing with fish on artificial reefs. And while we deal with some of that in Broward, one of our biggest issues is with beach nourishment. We have a couple of inlets. The beaches are eroding, and so we need to nourish or re-nourish these beaches. But then we're going to cover hard bottom that's been exposed because of the things that we've done, which I have a hard time with that. But DEP requires that if we're going to put sand on the beach, we're going to cover X number of acres. We have to mitigate for the hard bottom that we're going to be covering out there. So we need to mitigate. They won't tell us how. They tell us to come up with an idea. We did a project back in 2005 or so, and we put limestone boulders down because that's the best idea that we had. Limestone boulders in the nearshore hard bottom, which is fairly flat. It's an octocoral community, totally dissimilar. So now we've come up, and keep referring to Sarah's presentation, we've come up with some low relief modules are made out of concrete. They'll have limestone embedded with them, and we'll be putting those out spaced very specifically. We have to maintain the hard bottom sand ratio, so they will be placed with a crane in exact spots, and we'll be putting down close to 6 acres of these modules in the near shore. The monitoring on that is going to be looking at the benthic community. Fish do not matter whatsoever to the people in the beach and coastal systems that permit this. As far as they're concerned, apparently fish don't exist in the ocean. So we have to design a reef module that will mimic the nearshore hard bottom, that will be stable. And if, I don't want to pick on nymphs, but if nymphs has their way, that within 3 to 5 years will be indistinguishable from the nearshore hard bottom. So one of the problems that we've seen is brought up repeatedly in the talks is, why don't the communities on the artificial reefs match the communities on the natural reef? So we're going to put these things down. We're supposed to monitor them for 3 to 5 years because of beach nourishment. And if they don't have a composition and a species richness similar to the nearshore hard bottom, then we might have to put in additional mitigation. So we're talking $1 million an acre at this point. So because of the design, because of the placement, and because of the monitoring that we have to do afterwards. And then we have to find specific spots near shore that we can actually put these down, which is actually becoming quite problematic. So it's not just the modules offshore when you're looking at enhancing fisheries or the large commercial species, but we have some real serious and very expensive problems in the nearshore environment and some of the areas that are getting nourished where you have nearshore resources. I know Palm Beach County has them, and Miami-Dade has them also. Miami-Dade, or Palm Beach County, came up with some similar modules that they placed near shore. We're going to come up with some that are very kind of similar but different. But this is another aspect I think the artificial reef community needs to look at. It's not just enhancing the fisheries, but adding to the benthic community. I mentioned previously, back in 2006, for the monitoring that we did, we were looking at fish. That's totally been pulled out of our permit at this point. They want to know how many tunicates are there, how many octocorals, how many scalactinians, how many sponges, how many, the slimies that are down there. So at this point, that's what we've got to come up with. And if we don't, then we got to go to our county commission and say, give us another $10 million to put some more down there. And it won't be me asking. I'm too low on the food chain. I want to keep my job. But that is another consideration, I think, that needs to be discussed.
Andy, I know you wanted to.
So earlier, Chris spoke to kind of the ecological considerations of monitoring. I think for the state and county reef coordinators, you really need to think about your monitoring programs from the objectives that you've laid out for those reefs themselves. And as Robert said, through the NERDR process, there's a whole different suite of objectives that those reefs might be built for. The key, obviously, is to assess your objectives for why they were deployed and develop your monitoring program around that. I guess the other point I wanted to make is, when Todd or Dave put out a reef, those have been well studied. The stability, the longevity of those reefs, the composition, what species you're attracted to them. To me, there's opportunities here where if that work's already been completed, don't develop a monitoring program that essentially assesses the same information that others have already done and come before you. To me, the design and implementation of these monitoring programs from an ecological standpoint really just needs to focus more on how can we improve the scientific knowledge and management of artificial reefs in terms of how they're deployed, how they're distributed, ultimately how they affect the distribution and abundance of fish populations. And if you can learn from that, then obviously the next time you deploy artificial reefs, you'll have gained knowledge that will make that next deployment that much better and that much more beneficial from an ecological standpoint. But at the end of the day, it comes down to what are your objectives, and if your objectives have nothing to do with the ecology of the resource, then your monitoring plan should focus on economics or whatever social benefits you're trying to focus on for deployment of those artificial reefs. So really keep that in mind when you're developing your monitoring programs.
Yeah, and guess what? We're going to be having 3D printed reefs. We're already doing those now in Bahrain. We're talking about you can design anything you want. So think about that. The future of reefs is not what we've been doing for the last 20 years. It's what we can dream of. And you're exactly right. Let's think about monitoring what could be.
And one other thing, and it's all of our benefits to get better and learn from the previous experience, because artificial reefs are getting more and more expensive. So it's in our own best interest to learn as much as we can from those reefs and improve so that we can keep up with the cost per unit of reef deployed.
Go ahead, Brian.
My name is Ed Camp. I'm a researcher at the University of Florida, and I'm curious how the panel thinks that artificial reefs might alter the fishing effort itself, either maybe attracting fishing effort from different places or producing more fishing effort than existed before the reefs were put in. It seems that this could affect both the abundance of the fish populations, possibly the quality of the fishing, and certainly the economic impacts and the market activity around the reefs. So I'm interested in how panel is curious about investigating this and what's been done and what they'd like to see done in the future.
Louise?
Good question, Ed. And the thing is, you have to think, right, about the fact that all the different pieces of information, all these different metrics that we're trying to put into the stock assessment, right, are measured, unfortunately, at a very broad scale. And they are sort of like coarse metrics. And a lot of those parameters, for example, catchability of the fish, right, or selectivity of the gear that's being used to catch the fish, we have some estimates of those parameters, and we try to input those into the stock assessment and assess the impact of fishing on fish populations, but we know that we have already a fair amount of error, inability to really measure those parameters to the degree of precision and accuracy that we have to have. Now, throw into this whole process, this very large number of artificial reefs that might be changing, right? And I mean, you saw presentations over the last couple of days. They may have documented some of those changes in fish behavior and in fisher behavior, which is, I guess, more of what you're talking about. They will be concentrating perhaps fishing effort in areas where the fish then become more accessible to fishermen, and that will change catchability factors going into the assessment. So at this point, we don't have any of those issues really properly accounted for. I think that I know Will Patterson, for one, is conducting a study now with one of his students, I guess, that's looking at some of the selectivity factors associated with artificial reefs, or changing selectivity factors. And catchability would be another one that needs to be addressed. How we design studies that allow us to have a better measure of those things. Tell the truth, escapes me. I'll be curious to hear from other panel members if there are any other ways. But, and this is not supposed to be judgmental, my comments, in terms of saying there is something that's right or wrong about having artificial reefs there. I just think that as a scientist, my obligation is to tell you the facts as they are, and to make you aware that those things are interfering with the natural environment. One, they have to. It's like when you think about agriculture, right? Monoculture in some different areas, and we will change the ecosystem of those areas just because. And it's not necessarily bad for society, but it does impact the ecosystem. And the fact that we don't have a very good idea on how to measure those things and integrate them into our stock assessments, it impacts our ability, our ability to measure things properly and provide assessment results that are accurate to the point that we really can inform management well. I mean, that's my perspective on this.
Okay, but did you, Todd, and then
Yeah, I think this also gets back into, there are different types of reefs. We have reefs that are designed to attract fish and make them easy to catch. And we have reefs that are designed to produce fish. Attraction versus production, we already know this. I mean, if you put 10 telephone poles in a farm and you got a deer there, he's going to get shot. And if you put 10,000 trees there and it's a forest, the deer's got a chance of getting away. So we have to think about the quality of what we're building. Sometimes we can make stuff that's going to make fish come and get easy to catch, and it's going to be a management issue. And sometimes we can make stuff that's very complex and the fish have an advantage. Maybe they can go underneath and get, away. Just think about it from a logical perspective.
Andy?
Well, I think to add to that, not even looking at it from a construction ecological perspective about production versus attraction, give thought to actually deploying the reefs, because it certainly doesn't make my job easier as a fishery manager when you have readily available, publicly known reef sites that are easily found with GPS coordinates. That is obviously increased level of fishing mortality, especially if those reefs are close to shore. And so to be able to develop a reef program around the idea that some can be found, maybe some are publicly known, may help to alleviate some of that fishing mortality. The other aspect of this really, which goes back to Louise's arena, is the issue of, well, if they are increasing production, and how do we capture that? How do we, so to speak, capture this regime shift that might be occurring because we're adding all this additional habitat into the environment, and therefore the stock that we're managing or stocks that we're managing are more productive. If we can't discern that signal, if we don't know that that production is occurring, then ultimately what will happen is we'll underestimate the overall population size or abundance that should be out there, and ultimately the yield levels that can be taken from that fishery. And so that represents a challenge as well in terms of understanding the productivity of those artificial reefs relative to attracting people to them because they're readily known, and increasing fishing mortality rates because they're easily found.
I have a little bit of a different perspective on this. By placing those reefs closer to shore in shallower waters, being careful that you're not placing them so shallow that the fish assemblage will not consist of the target species for the consumptive users. And we'll talk about that because I think that's really the real issue here. By reducing the fuel consumption, I think we're reducing the carbon budget in the carbon dioxide budget part of it, and the environmental effects of burning fossil fuel to get at these reefs, by bringing them into shallower water so that when they are caught and they must be discarded, that reduced that you're lessening the reduction in pressure and the tendency of these fish to either die of barotrauma or be more easily preyed upon by barracuda and other species that are waiting for those regulatory discards. That I think that we really are giving a benefit side to the fishery ratio. But you know, there's always going to be, I think, a balancing act, and that's some of the tension we've talked about it, the tension and balance between some of these components of the artificial reef program. But I think that in the net benefit to the stock, I think, is by bringing those reefs closer to shore. That may turn into one or two more trips, fishing trips for that person. But from what I'm hearing from the stakeholders, when they want to go fishing, they want to go fishing. And if we can reduce the carbon and increase the survival of those regulatory discards, I think we're doing a net benefit to the system.
Anybody else want to add to the discussion about fishery behavior?
I'd like to say that Mexico Beach has been putting reefs in 20 feet of water. They have some permitted areas there, and they're noticing there's hardly any lionfish on those reefs. And when you put it in shallow water, you get a lot more growth on the reef. The sunlight able to reach it. And they usually in Mexico Beach put a juvenile reef, one that's designed for juvenile fish with a lot of complexity to it. They'll put a grouper type reef, made just a shelf for grouper, and they may put one of my big reefs and some of my smaller reefs there. And it's an overall, it covers a pretty broad spectrum of the fish, and they're doing quite well. And we're noticing that all of the big reefs that we put there, just about all of them have a jewfish inside. So we're doing things that we didn't realize, you know, were going to work that well. And I think if anybody's going to study something, that would be a great place to go and do it, because they have they've been monitoring it, and they have a lot of information too.
Okay. Holly?
Hi, Ron Coddington with Callaway Marine Technologies. I recognize the Artificial Reef Program Manager's challenges in permitting as far as time, et cetera, and I also recognize the reason why you permit large areas and have that permit for a long period of time. However, in a recent deployment, and I'll leave the project unnamed, but on a recent deployment, we showed up to place an artificial reef in a very specific site that we were directed to. And upon deploying ROVs on the bottom, we found 3-foot-high relief with large, very prolific stony corals and soft corals in the area. So we were at a permitted site. Obviously, that's not a location you want to be placing an artificial reef. And of course, recognizing that cost is always an issue for you guys. You don't want a contractor going out there held up when he's getting ready to deploy work, especially with marine equipment under lease or rent or whatever, or just under operating costs. What do you think's a reasonable time period between an initial permitting of a site and reevaluation or reassessment of that site to see if, with the dynamic biological changes that can occur, if that site's still an acceptable site for reef placement many years after the initial permitting?
Yes, and we take great steps to site our artificial reefs in areas where live bottom is not present. There's always the possibility that storm events can change, and we do have ephemeral outcroppings, rock outcroppings where that occurs. But I would say that the reef manager, what I would have done was I would have gone out the day before and made sure I would have scanned it and made sure that I didn't have a contractor on site with that problem. But that could have been prevented, I think. But that's just my perspective.
Yeah, go ahead, Pat.
I agree that the changes can happen fairly quickly out there, especially depending on the depth. And we're doing things a little bit differently in Broward because of the cost. We're permitting much smaller areas. We used to have these real large areas, but it's very expensive to permit those. And then we weren't sure we were going to have an artificial reef during the life of the permit. And then by the time possibly we got an artificial reef, we'd have to go through the whole permitting process again for another however many thousands of dollars. So we started permitting much smaller areas, basically something that would be the size of the artificial reef that we're going to put down. And then it's not near as expensive to do some ground truthing in that area to make sure that we're not going to be dropping it on any hard bottom. And oftentimes we'll go out there and actually ground truth it before we submit the permit application. Otherwise, we're just back to square one at that point. So instead of doing these very large areas, I know, do you remember how big it is, like a quarter mile on each side? It's a quarter mile on each side. If you maintain a smaller area like that, it's a lot cheaper and a lot easier to maintain. But then again, it's more project specific for the artificial reefs.
Chuck Morton, Hernando County. I'm talking with Hayward. Matthew's familiar with our area. He'd helped us put in a reef years ago. I like Mr. Walther's thing where you have a total package, for the juvenile, the offshore, and in our case, maybe even some mangrove development, in the marsh areas, as a nursery habitat, with some offshore. But my question would be, when a project has been approved or there's a plan used somewhere, if it's adaptable, it seems like we're all forced to reinvent the wheel every time we want to do anything. And it seemed like, if we got together regionally and you had a set objective and you had a project that was done somewhere that could, fit with minimal modification, that this should be able to stream up the permitting process, but it doesn't work that way. It works just the opposite. The other thing is, like on seagrass, we had to do some seagrass mitigation when we did a Hernando Beach Channel dredge. We had to lift the grass off the bottom where we were going to dredge. They transplanted it over to Weeki Wachee, which is where fresh water comes up out of a spring and runs down, and guess what? The grass won't grow. But you can't put anything there because there might be a sprig every 2 or 2.5 square feet, and then that precludes you because you have to have, what, a quarter mile, no seagrass around it, not even a sprig. So yeah, it went completely contrary to what Hayward was saying about the productivity of a reef module being able, pH balance to grow aquatic growth.
Any responses? You're all looking at each other.
we talked about this in our private meeting on the telephone, but we've all got a process that we go through to make reefs. And every county has their own county process. Every state has their own state process. The feds have a Fed process. As I go around the world, everybody else has got their own process. And they all kind of are designed to do the same thing. We all want to do what's right. The problem is these processes interfere with each other sometimes. And once in a while, my process comes to your process, and all of a sudden my process says to you, you got to build this someplace where it doesn't make any sense. This is where it comes to be people. We have to once in a while raise our hand and say, it's not going to work in this situation. That's why we have conflicts. And this whole talk is about user conflicts. I think we have a lot of conflicts in this country because we have a lot of processes. They're all designed to do the right thing. There's not a single person here who doesn't have a job that's not doing the best they can for their job. My job may be to protect fish, coral, the environment, some aspect I'm being taught to do. And the problem is when they all come together, once in a while, they're not the same. So how do we get, and this is a question for the panel too, how do we get all of our processes to line up? Because we all know what's right. So how do we get it to where, in the end, everyone comes together and it makes a better reef, it makes a better outcome? I'm not sure there's a good answer to that, but I want to throw it out there.
Luis, and then Jessica.
Well, I mean, I think that's a very interesting point. I mean, something that I actually was thinking about back here, you know, listening to all this conversation, that it wasn't necessary just focus on processes, you know, from the point of permitting process, approval process, or how do you do an evaluation process, but it's really development of an overarching framework for management of artificial reef deployment and use. I mean, this afternoon, I'm hearing a lot of different versions of artificial reef that are potentially developed to address different goals, right? And do different things. And like everything else that we do, you know, we could end up with too much of type A, perhaps not enough of type B. How many type C's do we have, right? And right now, what I don't know as a fisheries biologist that spends quite a bit of time, you know, trying to look at fishery population trends and, you know, make recommendations in terms of catch levels and assess the status of stocks. What's the health of this stock? What are the issues that I have? Is how many of those different types are out there? Are they in the right areas or wrong areas? So I can start trying to more explicitly integrate all of those potential benefits and impacts, right, into the way that we measure what's out there, we evaluate what's out there. So, you know, I think that having the different states and within states having different counties that have more discretion on how they're going to be permitting, they might be using different criteria, different timelines, different processes, like you're saying, right? And still, I mean, I don't see how we can actually come up with a management type of, for all of those different, you know, for the implementation of all those different uses of artificial reefs to make sure that they have a balance, that we are trying to balance them off. So I might end up really with the wrong idea that artificial reefs in general increase catchability of fish, and they are actually in those specific areas because they increase the success of fishermen of finding and catching the fish, they're increasing fish mortality. Well, that's probably just one type of artificial reef. There might be other ones that are unfished and are really restoring habitat, right? What would be the impacts of putting reef habitat in areas that over millions of years haven't had reefs, right? So species out there that we fish and manage have evolved over evolutionary time to be, selective processes took place to establish life fishery patterns that are basically hardwired. So for us to come and change those things, we might be impacting, and I saw, you know, some from Chris's presentation early, and I guess Bill's as well, and talking about if we put those things over here, we are now attracting the juveniles over here and preventing them from going over there. So things that took millions of years in terms of the biology of those species, right, are no longer really following the same natural processes, right? So those species, selective process that took place, set up seasonal growth and age and size of reproduction and all those biological processes to account for all those other things that right now we're not being able to measure. So to me, having some kind of an umbrella, and it's not management from a regulatory perspective, it's management from people getting together and say, well, can we coordinate what's going to be done so we have a better understanding of the impacts to the system as a whole, positive and negative impacts.
Jessica, did you want to?
Yeah, I mean, kind of the similar theme is what I was thinking of is I think that some sort of guidelines might work if artificial reefs, if there's one size that fits all, but there definitely aren't. And I would definitely hope that there are not. As we talked about before, different types of artificial reefs serve different functions. There's a publication, the Southeast Florida Coral Reef Initiative, and they had a checklist of different factors. And I mean, there's about 8 different considerations, concept, ecosystem, objectives, planning, construction, yada, 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 design, and about 5 or 10 questions under each of those listed in this table. There's so much individual variation from reef to reef that maybe that's something a working group or the agency could kind of come up with some super general overarching guidelines that would provide some guidance for when counties or whoever are looking to put in an artificial reef. But I would think that it's so case by case based on the specific goals and objectives and all of those factors that go into the chart above. I think it would be difficult, and it would actually maybe tie your hands if you were to try to come up with a one-size-fits-all system.
I think a lot of the problem that we have with the permitting process are the people that are actually processing the permits. I'm going to go back to the tire project here for a minute. When we started it in 2007, I applied for a permit from DEP, and we're doing a good thing. We're taking a really nasty situation and trying to rectify it. We're damaging the environment, so this is a way to help it without deploying. Actually, we're removing. It took me 9 months and 2 RAIs to get DEP to issue a permit to me. They were really concerned about any corals that might be killed. There are very few out there. Granted, are some going to get killed? Possibly. Is there turbidity? Is it going to be sediment that's going to be falling on the nearshore reef? Probably. If they go out there during a major storm event, I mean, it looks like chocolate milk that's out there. We're not going to create near that type of condition. But it was almost like if I had a growth that needed to be surgically removed, they would not allow me to cut into healthy tissue to remove the nasty tissue because I was going to be damaging healthy tissue. Are corals going to die? Yes. But look at the bigger picture. But then during that same process, we applied to the Army Corps of Engineers. I got the permit from them in about 3 weeks. 9 months, 3 weeks. So we're going through a similar process now working with the state. We've got $1.8 million. We hope we're going to get about 100,000 tires out, which is not insignificant. And the DEP gave us a permit in about a month. Army Corps, we applied for it, I think, back in August, and we're still waiting. So the process is flawed. I think they really need to look at, are we going to kill a little bit of seagrass? We're going to kill a couple of corals, but what is the general, what is the overall picture? Are we building a commercial project that's going to more damage the environment, or are we trying to do something to enhance the environment? But I think a lot of the people that go into these permitting positions are fresh graduates. They really don't have any practical experience. And so they look at everything as, as if what's the worst thing about it right off the bat. They're not going to go, oh, is this good? Is this bad? What are we going to do? They've got their blinders on. They got their checklist on. And until they get some more experience, or unless they possibly come from some other institution where they've gotten practical experience and working with artificial reefs or offshore construction. I think that's probably a big part of our our bottleneck getting permits in the South Florida area.
So
I'd like to comment on that. We have a wealth of information here. I'm really excited about this conference. I've just learned so many things. It seems like every time we have one of these, we have raised the bar, of the information that we have. And wouldn't it be great if we had like a committee in the state of Florida that would take the reef permits and evaluate them and have representatives from the stakeholders there, and they could make recommendations to the Corps of Engineers or the DEP. They would have somebody representing both of them, somebody that had the knowledge and all of the mistakes that we've made over the years, be able to incorporate that information in there too, where we wouldn't repeat those mistakes and streamline the process and make it much easier on everybody.
So one of my roles as moderator is to take the temperature of the room, and you all are starting to get a little bit restless. We actually have the Army Corps, a question from the Army Corps, which is somebody we don't have representative on the panel. Unfortunately, as you see, 8 people talking can really take a long time, so we just had to limit the numbers. But what I wanted to do is just take 2 minutes. Don't leave the room. I want everybody to stand up and stretch, okay? Just go ahead and stand up. Huh? No. Don't leave the room. I know better than that. Just kind of stretch it out a little. You guys are getting a little fidgety. We've got about another hour of this. If you were in one of my conflict situations, I'd actually make you do a little Simon Says, but I won't. I know. I've had a University of Florida dean write their name in the air with their elbows and maybe other body parts. Just giving you guys a couple minutes. Sorry, I could just see the group moving around a little. Huh? No. Okay, can everybody go ahead and do one final stretch? Now I feel like a yoga instructor, right? Deep breath. Don't tickle me. Okay. Thank you for humoring the moderator for that couple of seconds. So we're going to get started again. I have one question lined up. I've got another question, stand up. Now I've got 4 questions. So 1, 2, 3, 4.
Hi, I'm Bev Lawrence. I'm with the Corps of Engineers. And this is in response to the question over there, or comment over there, when you were saying you deployed some material either on some hard bottom or some coral. But we do have a special condition in our permit which says you have to monitor the area before you deploy, and it's at least a year in advance. So I don't know if that's something we need to tweak and change, because I'm surprised that you went to deploy something and then there was some live bottom it could be live bottom because of sandy areas, but then you said coral too. So we do have a special condition that should have addressed that in our permits. Yes.
Yeah.
Howdy, Tom Hilton from Texas. One of the presenters showed all the types of species that are typically found on a reef, like cobia, red snapper, triggerfish, and he classified them as all being basically reaching the threshold of their being overfished. And then another presenter showed the stomach contents of other fish, whether it's shrimp or smaller fish, whatever. My question is there any type of artificial reefing program that is geared to grow the type of fish that these fish eat? And this could be a possible solution to the attraction production debate, in that you're not trying to attract fish to catch. You're basically providing a habitat to grow the bottom part of the ecosystem, the food source.
Several years ago, we I wish we could. I wish I could say resoundingly yes, we can do that. But several years ago, we looked at a reef design to try to incorporate a prey species component as well as a target species for the consumptive uses. But we wish we knew that much about artificial reefs, and many times, whatever you place down there is going to be utilized by settlement that is coming from the plankton, and most of these spawners are their dispersal. So the processes and stochastic is the word that comes to mind, but it's more random that these settlement of these species occur in these locations. And I wish we could. It would be a great goal, maybe a stretch goal for us, but it certainly is worth thinking about, if not attempting.
We do a lot of nursery reefs in particular. I mean, everything from planting mangrove trees, which put the roots out there, to doing inshore estuary type stuff, oyster reefs. There are ways of doing that. It's not the traditional artificial reef that you think about offshore, but there are a lot of habitats that are designed. And again, as Robert said, there's not one or the other. You're always going to have a big fish that comes through where the small fish are. But you can definitely design reefs for very specific purposes if you know what you're doing.
Andy?
Well, and certainly reefs can be designed for different life histories. In terms of your question with regard to the prey, keep in mind, though, a lot of these species have a very wide diet, and a lot of them are feeding in the benthos. So the artificial reef itself is really attracting those fish in and then allowing them to feed in areas where they might have previously not eaten food, but it's not necessarily intended to produce or increase production of those benthic species. So you're really talking about the prey in the water column that potentially would have to be enhanced in order to allow additional productivity.
Kind of building off what Todd was saying, my first thought was, the more basic you can get to mimic the natural habitat types, it might not be targeted to be increasing production of the bait fish, but the more you mimic those natural habitats like the oyster reefs or like the mangroves, then you're going to be building the bottom of the food chain, and it's just going to carry up from there. And I would love to hear, like I said, more when people talk about artificial reefs. Like I said, I think they usually think about those big fish attractors, and I'd love to hear more dialogue, more conversation about those base level types of artificial reefs too.
We've seen that quite a bit on some of the inshore reefs we've done where we're building with oyster bars and that sort of thing. You're bringing bait fish in there immediately, and then in a very short period of time, you've got redfish and other fish in there feeding on the bait fish. So it's starting at the bottom of the food chain and works its way up.
Let me move on.
Well, actually, I had one thing, and it's important enough, I think, that it deserves time, is that I'll be the first to say artificial reefs are not the magic bullet. If we don't have good water quality, if we don't have healthy seagrasses and coastal, if we've modified the system, then we don't have enough artificial reefs to rectify that problem. I think we need to be holistic and keep the system healthy, so we put artificial reefs in there and they're doing what we want them to do. Thank you.
Can we get an amen?
Yeah, that's good. Thank you.
Hello, my name is this on? My name is Eric Slokowitz I'm the state reef coordinator for the state of Maryland. And I guess I have a question at the federal level. NOAA is actually very active with oyster reef restoration currently in the Chesapeake Bay. It's a multi-agency effort with state and federal partners. But it seems like NOAA has not been very active with offshore reef research or development, perhaps since the earlier mid-'80s with Dick Stone, who actually was a co-author on my state reef plan. Can you give me some understanding of perhaps why NOAA has not been as active in that type of offshore reef development or research? Is it because of the mortality concerns, the attraction issue, or is it more complex than that? And this is not necessarily, it's sort of out of my curiosity, but I also get that question from the stakeholders that I work with in Maryland. Thank you.
I'm really not the right person to actually answer that. I know we have a couple of folks from my office that are specialize in habitat related work, and so they're here and I can point you in their direction to maybe help with that. I think the answer is probably more complex than what we've discussed in terms of fishing mortality. We also have the challenge at the federal level of multiple agencies that are involved with artificial reefs, from a permitting standpoint with the Army Corps to oil and gas through BOEM, and obviously our agency, NOAA Fisheries Service, in terms of management of marine resources. And so I think that brings an added complexity in terms of who's responsible, what is each role and responsibility at the federal level across all three of those agencies. But as far as why we don't do more in terms of artificial reef research and management, I really don't have an answer for you.
It's Patrick here.
Patrick Smith with California Ships to Reef. So a little bit different perspective here, and I'd like to ask the opinion of the panel members of a situation that occurred not too long ago. California Department of Fish and Game, now Department of Fish and Wildlife, had kind of a rocky beginning with artificial reefs. It was not a love-hate relationship. It was pretty much a hate relationship. However, that opinion was not everybody's opinion. As a youngster growing up, I was diving fairly early and very serious about it. And as such, I was taken into the confidence of some old-time divers and given access to a home-built reef. Now, when I say home-built, this whole thing is kind of going back to the trash on the bottom and Pat's issue with removing tire reef. But whoever built this reef, and it had been there for some time when I started diving on it. So probably 10 years previous, it was approximately half the size of a football field, and this had all been placed by, I guess, an individual. Material consisted of porcelain toilet tanks, a whole lot of clay waste pipe material, concrete rubble, and there was concrete pillars as well, not real big, probably 6 inches across and maybe 10 to 12 feet, carefully placed. These were all hand-placed items. This was not dumped and left. By the time I was exposed to this was an incredible environment. It was very lush, it was live, and it was set close to a nearby natural rocky environment, but it was a kind of a not very robust rocky environment. The artificial part of it had an incredible ecosystem going on it. Many different varieties of fish, inverts, in a couple of ends that were even a little bit shallower up toward the 60-foot end, even had Macrocystes giant kelp growing on it, which was not common in that area. In the recent past, word of this particular reef got out, and it went to the Department of Fish and Wildlife, who immediately claimed it as junk on the bottom and spent the better part of $1 million removing it. I understand junk on the bottom. I understand people taking their refrigerator out and dumping it. This was not done like that. It wasn't permitted in any way, shape, or form, but it was established and it was healthy. And I just wondered what the comments, the ideas this panel might have on something like that.
Well, I think something like that, I probably would have left it down there. It has been there for how long?
I've known about it for at least 20 years, and I suspect, given how robust it was when I got it. I'd known about it for, well, now it's been 30 years, and I suspect it would have been there probably at least 10 years before me, 5 years at least.
Yeah,
so a quarter of a century.
Yeah, so 25 years is obviously stable. As
Yeah.
I mentioned, stability would have been the biggest issue if something was dumped in our county. I mean, that's why we're trying to get the tires out, because they're not stable.
Exactly.
And everything else is down there pretty much is, unless somebody's just caught violating basically the rules that we all have to play by. If something had been down there for that long, would essentially probably would have just grandfathered it in, especially if it was showing stability and had a good community on it. Yeah.
There was a lot of thought in that direction, particularly given the cost, the financial cost to remove it, not even looking at the environmental cost. So I'm just curious as to this learned panel's impression of that.
Yeah, my thought would be, I mean, if it was down there for 25 years or longer, and it's doing its intended purpose, I mean, I think you would really should you're grandfathering it in. If you're building artificial reefs to create additional habitat, and this one is working, why not leave it there as opposed to spending all these dollars to take it out and then have to recreate that somewhere else?
I'll just chime in, since I was one of the ones, I think, who spoke up against the illegal dumping before. And that's what I said before is, once it's become established and become habitat, then it should stay as habitat. But I don't think that gives folks a pass to do it moving forward. So that's all. But yeah, absolutely. I think that was ridiculous that they would go through that effort to remove what sounding like a viable habitat.
So Brian has somebody with a question, but I just wanted to make you all aware, if you see me on my phones, because Brian and I are texting about who's asking questions, I'm not doing anything else. It's just we're trying to do the sign language and it's not working. So like, do you have somebody? So I realized I'm doing that in front of everybody. Go ahead, Brian.
Sounds like we have significant opportunities and challenges with our artificial reef programs. I was just wondering from the panelists, what's keeping you up at night right now about artificial reefs?
You stole my final question.
I'll answer that, and I think it has to do with the lionfish. I'm scratching my head as to what is what's the mechanism that is creating such an abundance and an infestation of the reefs that I'm building, because I build them and they're like my children. I don't want them harmed by the lionfish.
Anybody else?
Yeah, couple of things that I've noticed, and we know that the artificial reefs and the natural reefs really don't work the same way. And Amy showed a picture of a blackfin snapper on an artificial reef, and it's interesting in Broward that we see blackfin snapper on artificial reefs a lot. Juveniles, we never see them on the natural reef around. And we see the lionfish primarily on the natural reef, and we see them a lot less on the artificial reefs. On the tire field, I was out there for, I don't know, an hour, scootering around. There were some barges and everything out there. Didn't see a single one. Perfect environment that you'd think you see a lot of the ships that we're on. Occasionally see them, but for the most part, we don't. You're going along the natural reef, and that's where we're running into them. I don't know, just seems odd to me.
We think this is a great question, so we're actually going to ask the whole panel to answer it, in brief. Just so you know, what keeps you up at night about artificial reefs, right? So, Andy.
Well, actually, my dog keeps me up at night, not artificial reefs. But I guess, I've been out of artificial reef research and science for now, I guess, 15 years, and was invited to provide my fisheries management perspective. I guess what would keep me up if I was still heavily involved with this is that although we've made progress in kind of wrestling and dealing with this attraction production debate, there's still so much uncertainty about it, and there's still so much that's yet to be known and understood. And I think someone said it best today that it is probably more like a continuum, but it's so species specific, it's so regional, and there's just a myriad of projects that have been completed over time, and depending on what environment, what species, how you deployed the reefs, you can come up with a different answer to that question. And that was the main impetus of my master's thesis, was looking into factors that affect attraction and production. And at the end of the day, if I'm going to lose sleep tonight, it'll be the fact that we're still wrestling with that very question 15, 20 years later.
And to answer, directly to your question, I would say nothing. I fortunately sleep very well, but I would go back to what Pat mentioned. I think it was maybe 10 years ago, one of those previous artificial reef summits, and I think it was Dr. Siegler or Spiegler? Spieler, yes. And he gave a presentation, maybe it's longer than 10 years ago. And then I saw one of his papers come out and I read it in detail. And the fact that, you know, the communities were not comparable, really, right? And that the more that we seem to put those things out there, we might be creating a substitution, so to speak, of our natural system, right? And it's like bringing exotics, right, for gardening, for example, because some of those other species that are not really natural to our environment may be more attracted to the artificial reefs, seem to be, from his presentation and some of the other things that I've read afterwards. So yeah, I mean, are we causing a shift in the actual ecosystem as a whole by creating environments that are more conducive to settlement for some of these exotics or species that were not part of our ecosystem? You know, that is something that could have a huge impact on everything that we do, you know, in terms of fisheries and marine science and management in general. So that would be my main concern.
You know, I guess mine's a little bit different perspective on it. I mean, I see our organization as a support method, a support group really for the various counties and groups on what you're trying to do, in that we can help provide some funding, we can help provide some manpower and that sort of thing for it from our organization. So for us, I mean, we've always been involved in habitat to a certain extent, but we've really gotten very involved in the last 3 or 4 years. So from a national standpoint and a state standpoint, it's gotten to be very important on the things that we work on. So I guess what would keep me up at night is how do we, you know, best utilize that and to as support for the various groups around and things they're working on.
I can see Todd reaching first and then Jessica. It's whoever reaches first. Okay.
We can just go down the road then. Yeah, I have a very loud cat. So, but say he'd make a perfect pet for a deaf family. But I think I don't want to underscore, or I don't want to diminish the importance of the lionfish issue, because I think that is huge from a fisheries perspective. But I think my biggest concern is that the media and the public at large see artificial reefs as a magic bullet. And speaking specifically to the counties, who I'm so happy to see so many county representatives here. That's great, because I work on the Gulf restoration issues. My biggest concern is folks that might look at artificial reefs, building artificial reefs as a main means of ecological restoration. And I was so glad that it was actually one of the counties who said that you got to first deal with the water quality. You first got to deal with your other habitat issues, that artificial reefs are one tool, but they're not a magic bullet. And there's so much more that goes into ecological restorations than just building artificial reefs.
For me, what keeps me up at night is making a reef that is as close to the natural reef as I can possibly make it. Reef ball's been around for 20 years. We have 100 different designs, hundreds of different styles. Every day we spend trying to make that a little bit more natural. We're probably only 80% there. Given no permitting, no issues whatsoever, someone invites me in and says, build a reef that's natural, I can do it about 80% right, close to the species composition, but I can't quite get it perfect. Sometimes those non-native fish come in, different things happen, so we have to keep trying. We have to keep getting better. And I've been with this group for 20 years and watching you all get better every time. And when we get together, each time we get a little bit more science, a little more monitoring, a little more knowledge, and we understand that we can modify what we're doing just a little bit to make it better. And that's what's going to keep me up at night, is how can we make it just better next year? We're never going to get to 100%. It's never going to be the magic bullet, but it can be better than it was yesterday. That's all I can say.
I think Todd said it all as far as contractor part goes. We agree on that. We've had these conversations amongst ourselves, and I worry about, what direction we want to go, what's the next thing, but I also worry about the regulatory process. It's changing and sometimes makes reefs more expensive to install, and some of it I feel like it's unnecessary, and I really wish we could have some sort of standardization where all the counties kind of came together and said, with the Corps, DEP, and have a group that would work through these problems. And I think we could make them a lot more reefs for a lot less money if that was done.
Hi, I'm Richard Black from Florida Dive Connection, and I'm sort of here as a representative, or I'm here personally representing the recreational dive community. So this is somewhat of a selfish question. Last summer, I had the opportunity to have a conversation in a Chick-fil-A in Pompano Beach with a guy named John Chatterton, who is arguably the most famous wreck diver in the world. And he looked across the table and he said, artificial reefs are the future of the recreational dive community. And I've got that recording if anybody else wants it. So with that, this is the question. How do you all feel, or what do you see coming down the pike with shipwrecks, the Oriskany's and the Mohawks and the Lulus and the Vandenbergs? Are we looking at more of those, less of those, or what do you see happening in that area?
Well, we're in Broward County. We're trying to get our hands on a 300-foot ship and put it in recreational dive limits, which will be definitely probably 3 times larger than any other ship that we have within the limits. And we're pretty excited about that. As I mentioned earlier, economics is probably one of the biggest reasons that we sink artificial reefs in Broward for fishing, but mainly for the dive community. So we were talking, a few of us from Broward earlier, about the Spiegel Grove. It's such a big vessel that the dive operators could do 2 tanks. They could do 2 dives on that vessel. When you're doing that, you're taking those divers off the natural reef. You're easing up on the pressure of the natural reef. I'm not sure exactly what the appeal is with the ship for divers, but they do seem to love it. The bigger, the better. And so if we could get our hands on some good sized ships and sink those and help relieve the pressure on the natural reef, that would probably be where we would like to go with it. The problem is the money. We just don't have the money. Our artificial reef budget is 0 at this point. It's whatever time I can squeeze out of my budget, whatever time Ken Banks can squeeze out of his budget of work for us to work on it and apply for a grant. We've got the city of I think Pompano Beach, the Isle Casino. There's a number of different people that are chipping in to get this ship and possibly sink it. So the county is just providing expertise and some permitting issues. So I think that was probably where we would like to go with the artificial reefs in Broward, is getting some more ships that would take the diving pressure off the natural reef. And we have, a lot of people may not know, we had Port Everglades, we had the Navy Surface Warfare Center there. When a submarine is commissioned, one of the first things it does is come down to Fort Lauderdale and run up and down the coast and get silent. The submarines make all kinds of noise, whether it's electronic or physical or whatever. And so they're not perfect when they come out of the shipyard. And so there's all of these cables and sensors off of Fort Lauderdale, and they run up and down, and they record all the noises that are coming up and come figure out ways to make them quiet. And so it's not unusual for us to be out there and a submarine will pop up and just spend the day running back and forth. So they've got all these cables out there, and the divers or boaters aren't supposed to anchor on the natural reef, but they do anyway. So we're out there doing something. I forget exactly what it was, but as we're swimming along, we came across this cable, and it had been hooked by a recreational boater. The anchor got underneath the cable. They couldn't pull it up, so they put their engine in there, just trying to break it loose, trying to do something. And this cable probably flattened all the barrel sponges, probably an area about the size of this room. They just drug this cable and sheared everything off. It was just horrendous. It probably happened within that week. So if we can get people off the reef that are doing stuff like that and put them on some of the larger ships and let them dive or fish or do whatever there, then, you know, that would be a commendable goal for us, I think.
The economic analyses that have been done, and we heard one from Bill Huth today, clearly give the stakeholders, and it's not just divers, I think the fishermen as well, and the organizations such as CCA, who have been very supportive of artificial reefs and other issues. But really the issues are how do we gather up enough funding through the existing means, and really if it's a grassroots effort, if all of the dive equipment manufacturers and all of the tackle equipment manufacturers, if the boating, if the stakeholders that benefit, the hoteliers, if everyone got together and and requested the funding to make these very expensive projects happen. The Oriskany was how much, John? $18 to $20 million. It could happen. But it will really require more than just a staff guy, putting it in his budget, to get that kind of funding available. It can absolutely happen, but I would put it back to the community to make it a community project.
Okay, so we have one more question from the audience, which I'm going to ask our panelists to answer briefly, and then I'm going to ask the sort of final closing question that was almost stolen from me by a gentleman over there, but I've now changed it. So,
besides some of the obvious failures like the PCBs, tires, and vessels, not landing upright, what are some failures you guys would share with other people to possibly give them ideas that they could use?
Lessons learned. I think this goes back to the county guys again, right? Sorry, but we might.
Did I mention the tires? I'm just curious. Let me think about that. Well, one of the things we do just to kind of protect ourselves is to make sure that our liability is really limited. We have these fairly narrow sand stretches between the natural reefs. And when you're anchoring a vessel out there, you have your anchors going down, you've got a lot of scope on the line, and it's tight when the vessel's on the surface, but as it starts sinking, all those lines are loose now, and so it gives the ship a whole lot more sway. And if the current catches it right, you really don't want that thing that's supposed to land in the sand to end up landing on the hard bottom. And that's when things get really, really nasty and really, really expensive. Thankfully, that hasn't happened with us. But one of the things we really try to do when you're putting a reef down in a very specific spot is we try to make sure that the contractor has liability for that vessel until it actually hits the bottom. There is some talk about, once it's towed out and it's anchored, then we take responsibility, or the city or whomever is trying to coordinate it takes responsibility. But we make sure it's in our agreement, so we don't take responsibility until it's actually sitting on the bottom. So just a little CYA there.
Well, you may not have known me when I started this job, but I had a full head of luxurious hair, and it's always. I mean, I'm on my way to 200,000 tons of reef material under my belt, so to speak, or above my belt now. But I think there's always you always are worrying about those things that you wish you could control. Try to get it as close as you can to perfect, and then you just have to say a prayer and hold your breath and do your best. I would say there's always going to be lessons learned. Even when projects go right, you always look back and say, gosh, I could do it a little bit better next time. But I appreciate the question, because I think it's part of a good project manager is always looking out for the things that can go wrong and trying to avoid those, and always looking for just a better way.
So my final question is for the entire panel, and it's, pardon me? Oh, apparently the acoustics in this room are good. And it's actually sort of a counterpart to earlier questions that's asked. So I'll give you a few minutes to think about this. But thinking about the booklet on artificial reef management, and thinking back 5 years ago, we had our last summit, Okay, so that was January 2010. And if you think about all of the things that happened around artificial reefs and our marine ecosystem during those 5 years, now I want you to project 5 years in the future to our, or sooner, depending on how the committee feels about organizing another one of these, to our next summit. And you're back here or wherever we are, and I would like you to think about what you would like to be able to say about the artificial reef program in Florida 5 years from now. So that might be what you would like to see happen. And you've all touched on this a little bit, but this is sort of the final message to the audience. What you'd want to be up here to say about the artificial reef program in 5 years. Luis?
Well, I hope that I can come back in 5 years and say that we have a better idea of how the artificial reefs may be interacting with natural reefs and impacting fish population abundance and distribution, and that we can probably account for those factors explicitly into the way they assess the stocks, and we have a good idea of really what those impacts are. And if I can, add something else is perhaps, a discussion by this group of potentially considering, something like a discussion of a management framework for the deployment of artificial reefs that produce sort of like a coordinated blueprint of what we want to have out there over a geographic scale that is meaningful. And we can think about that in terms of, for example, marine spatial planning. Not necessarily to say we are talking about marine protected areas or closed and open areas, but in a sense of kind of like zoning. What are the things that we want to, we all live in residential areas, and if somebody puts there a big casino, everybody complains because, that doesn't belong there. Down the road, there might be something else that's more focused on recreation or those kinds of things where we can look at the broad landscape out there and say, what areas do we need to have perhaps reefs that are more focused on increasing fishing opportunities versus other areas where they are more focused on increasing recruitment or nursery habitat. What is the restoration component there of the habitat that we are trying to achieve? I think something like this would better integrate. I don't see right now an alignment between how we think about deploying and using artificial reefs and the way that we manage our fisheries at whatever scale we want to talk about. And I would like to see them more explicitly accounted for. I think it would be helpful all around in terms of our understanding of the system and how we manage it.
I'm going to go down the line if that's okay. So
I guess a couple things. One is several of the speakers on the panel have pointed out, and several of the questions been asked about coordination. And hopefully in 5 years I could come back to you and say that there's been a grand improvement in the level of coordination that occurs between the federal and state level, within the state level, amongst the counties, that brings in the contractors, the people that are deploying these reefs, and that there's a more cohesive framework for permitting, as well as just overall structure of how artificial reef programs work. Also, from a kind of a research scientific perspective, I'd hope the same could be done in the scientific community in an effort to answer or at least better understand many of the challenges that we continue to face with artificial reef management as it relates to fisheries science or stock assessments. There's still a need for, at the federal level and working with our state partners, to conduct more research on artificial reefs, in particular with fishery independent surveys and how do we monitor and track fish populations on artificial reefs, and how that gets included in our assessments of and evaluation of the status of those populations. So I think there's a lot of opportunities here to help improve upon our science and management based on that integration. And I'll leave with, I think, a similar comment that has been made in terms of the use of artificial reefs. And I heard this comment a year ago when I was at another conference, a different topic, but the statement was made, beware of the shiny bauble. Artificial reefs aren't a panacea. And as you can see, there's a tremendous amount of complexity to artificial reef use and management. They have intended objectives, and use them to obviously those intended objectives. And hopefully, for my job, we can, when you're deploying reefs, you can focus on the ecological benefits and how they can help to enhance productivity of the system and ultimately lead to greater opportunities through fishing.
I actually have two. One is the human dimension, and I think we've had a lot of interest in folks that are concerned about the stewardship of the resources at the grassroots level. And I think we've got some nonprofits and some volunteer groups that can assist our management community in understanding more about artificial reefs, but also minimizing the risks that those reefs may play in trapping marine life and things like that. And then the other, and I'm really very hopeful that our ability through technology will help us answer the myriad questions that we still have about artificial reefs. So between those two, the human element and the emerging technology, I'm just really looking forward to seeing everybody back in 5 years. I hope I'm here too, but I just I'm very hopeful, and I have a positive outlook towards that.
Might start getting a little harder as we move down the line, as we're getting all the low-hanging fruit here. But
You can say ditto, right?
no, I got another one. I got a different one. So we have the regional updates, and now I can't really speak for what's going on the western part or in the Panhandle area, but in South Florida we have, with DEP, what's called the Coral Reef, Southeast Florida Coral Reef Initiative, because it's recognized that the coral reefs are not county specific. We need to manage the coral reefs on a regional basis. And I think we probably need to look at doing the artificial reefs that way also. I just mentioned that I have a limited amount of time. Sarah does, Janet does in Palm Beach County. And by pooling our resources and combining our experience and expertise, we might be able to take a regional approach to artificial reefs, pool our limited resources, and create a better product than what we have right now, rather than worry about what ends on a Broward County line and 100 feet over what begins on the Miami-Dade County line.
I would hope that when we come back in 5 years that we could have been able to build upon our support. Again, I kind of see that's where our group is as a support group for what a lot of the counties are doing. I think we can help on an education process, bringing awareness about artificial reefs, but not just the reefs, but the habitat as well, because that's just one of the many tools that are out there. But it gets it out in front of a much broader group as well. So I think if we can do that and we're back in 5 years, then, we just continue to build on that support.
I'm just going to do a couple quick bullet points. So in 5 years, I'd like to see lionfish on every menu and under control. Definitely like to capitalize on the opportunities that are going to be presented to the Gulf counties, presented by the BP. They see these NERDA reefs, a lot of great information come out of that. Would really like to see more reefs focused on the ecological function versus the fishery function, like we heard about in the talks earlier. And then, I think the folks in this room, they really get that. They get all these concepts. I would like to see all the information that we have here in this room, and I would like to see it more prevalent in the general fishing community and the decision makers and just the public at large.
I hear funding is probably one of the main problems that we have. And I think we should do more education to the public. There's so many people that don't even know what an artificial reef is. And to give you an example, I bought a ship. I had no idea what I was going to do with it. I'll buy anything that's a deal. And and
I've got some land.
So I bought this ship, and I'm bringing it in the Intercoastal Canal in Alabama. And Alabama's never bought a diving reef before, and so I didn't even consider them. I thought, well, maybe I can sell it to somebody in Florida, maybe Mississippi, maybe Texas. I don't know what I'm gonna do. Maybe I have to scrap it. I don't know. So it's coming into the Intracoastal Canal in Alabama. Somebody put it on Facebook that it was the largest vessel to ever come into the Intracoastal Canal. When we got to the Intercoastal Canal, there were thousands of people on the side of the canal cheering us on as we came in. And next thing I know, I'm getting contacted by community leaders, and hey, we want this ship here in Alabama. And I was like, it's going to take $500,000, guys. And how much money do you have? We don't have any money. And I said, well, I'll give you 6 months. If you can raise the money in 6 months, I'll sell it to you. Otherwise, I'm going to contact these other people. In 5 months, they raised $600,000. And one restaurant owner put up $250,000, the Lulu restaurant. And so it can be done. And and I saw a guy on a YouTube that he was pizza delivered, and he got stiff for a $5 tip. And the next day got on YouTube, and the next day got $2,500 donations. So it's possible, but we just need to market artificial reefs to a wider range of people than what we have. And the benefit, also the benefit for tax dollars, it needs to be communicated to the leaders and the politicians, let them know it's the best deal around. You can build a kids park, a skate park, whatever. You're not going to get the return on the investment that you are for an artificial reef.
That's pretty hard to follow, David. I would say for me, the most important thing is habitat. We are building habitat, and humans are destroying habitat. This group, I've been watching you guys over the last 20 years. Every time we come back, we get smarter. And what I want to see in 5 years is all of you to still be here, and all of you to keep spreading the knowledge that you're learning. Even those of you that are retiring, don't disappear on us. You have a lot of knowledge. Keep doing what we're doing. We're getting better every year, and let's just keep getting better.
Thank you. So I'm going to give the panel a hand. Here, we're at time. Thank you. We think that was a great discussion. We're actually out of time. Oh, okay. So thank you guys. This was we were actually really excited about the ability to have this discussion. I think it was really fruitful, and we really appreciate you all spending your time with us for the last 2 hours and 15 minutes. As per usual, we do have a couple of housekeeping things, and then Brian's going to do a few door prizes. First, we want to remind you we have evaluations in the back of your packets. Again, if you're not going to be, actually just everybody come back tomorrow, right? But if you can't, please put them in the back. The raffle tickets will be sold until the start of the social networking event, which starts at 6. And also during the networking event, they will be pulling the winner for the wetsuit. Okay. I want to, again, thank our sponsors for allowing us to have the networking social and a little bit of food tonight, because that was an addition. So I want to keep acknowledging the contribution they've made. I'm totally forgetting things. Oh yeah, so once we're done here, I'm gonna ask for a few more minutes of your time if everybody could stand up, walk downstairs, and we're gonna sit in the lobby. It'll be pretty clear where to go, and we're gonna do a group picture looking up at our photographer, Tim. Sorry, I was gonna say the evil Tim, but it wasn't the right one. Wait, no, it's just, sorry. That was
Inside
a total inside joke. Anything else I'm missing, guys, on housekeeping? Oh, yeah. So we had a few other people sign up. Actually, we had quite a few people sign up. So we're now up to about 180. So we're at record attendance for the Artificial Reef Summits. And we're pretty excited about that.
And yeah.
And the final thing is, as many of you know, we are streaming this live, and we have people watching from LA. We've gotten a lot of feedback from Gainesville, which is our sort of home office. And people are really saying that it's great quality. So we do want to thank our live stream team. And New York. Okay. So we've got people watching it from all over. And the recording will be available after the fact, right? So if you want to go back and watch one of the presentations, or you can do so. Okay. That it? We are working with the presenters, and if they are amenable to that, then yes. In some cases, and I don't have any answers, in some cases it's unpublished research, and so that we can't do it. But those who will allow us to, we will be putting PDFs of those files online. Sorry for the presenters that we haven't asked yet, but since you asked. It'll be on the Artificial Reef Summit website, which you registered on. And then we'll probably try to figure out if we can house it on both Sea Grant and FWC for future use. And we will send you all participants emails after the fact with that information. Okay. So very briefly, go downstairs, do a photo. 6 o'clock is networking social.
Door prizes.
And we start tomorrow morning at, everybody know? 8:15.
John Perkner. John's here. Okay, John.